So we discussed what is the use of Gitops already. So let's jump in. Why we need Argo CD? So already we have covered some of them. So basically Argo CD is a Gitops tool that's famous for multiple reasons. So one reason that attracts people is it is having the powerful UI. And then and we can give the Argo CD access to every team based on the RBAC defined for them. So they can only view their specific application, so not the other team's application. So for that, it is quite useful to provide access to other application teams as well. So that's one other advantage. And then CD becomes simple. So basically, if we'll have to use a CI/CD pipeline, then we need to define the trigger. Okay. So define the trigger like whenever there is a commit to the repository, then you will have to have a trigger. So choose either a manual or automated trigger. So then it has to invoke your CI pipeline, and then once the image is pushed, then CD pipeline should trigger automatically, and then it has to deliver your manifest to the cluster. So there is a lot of steps involved here. Okay, so there can be high chances of errors. So in any step, if there are any problems, then your sync will fail. So it will not be synced immediately. So there needs a manual intervention to just send the manifest to your cluster, right? So that involves a lot of work, and then teams has to be involved to fix this automatically. So again, if they have to do a rollback, then they'll have to run the respective pipeline and then choose the respective revision, and then you'll always have to have a rollback feature configured in your CD pipeline. So what is your production release, and then what is your rollback release? So these two versions you'll have to always maintain. So yeah, so this is how it will work. But with Gitops, the CD is taken out of picture. So your CI pipeline will still remain the same until pushing the image to the image repository. But when it comes to CD, so if we go for Argo CD tool as Swarna tool, so with Argo CD, we can have Git as a single source of truth to manage your infrastructure and applications. So your Git will be your source of truth. So whatever is in the Git, so whenever there is a commit that has happened to the Git repository, immediately your cluster will pick up the changes and then deploy it in the cluster. So you don't need a manual intervention, or chances of errors are less prone. So with this setup. So that's why this Argo CD is needed. And then again, it is a declarative approach, which means you are not running any kubectl or helm command manually. Okay, so it's all automated. So behind the scenes, it knows if you are using Helm or Customize based on the configuration that you give in the Argo CD application, it just detects and then it deploys in the cluster. So, and then the rollback is also easier since it is a Git. So it will have all the, so based on the which strategy you are using as a Git, like whether you are targeting any branching strategy, or then if you are having a tagging based release, or specifically if you choose main branch as your release strategy, then whatever changes there in that branch, it will be picked up and deployed. And then it will always have a version map. So for example, if I do 1.1 release today, and tomorrow if I am planning to do 1.2 release, and then if for some reason 1.2 release fails, so then we always have an option to roll back to the previous version, so 1.1. So you can just with a single click, you can do a rollback. So version control is possible with Argo CD. And then visualization of app is available via web UI. So you have an Argo CD UI, and then you can do a manual or auto sync. So both are available. Yes, someone raised question, right? Yes. Did anyone raise your hand?
No, I just asked whether we can you see Flux CD, Argo CD, everything comes under the same umbrella, right?
Yes, we were talking about what is the advantage of choosing Argo CD over Flex. So you can choose any CD tool in that case. So whichever is supporting the Gitops framework, it should work for the Kubernetes environment.
Okay, one quick question. So I started working on this one. That's why I'm asking this question. So my architect told me, like, it's a no need to use any Argo CD or Flux CD for now. He asked me to do a push-based mechanism from the GitLab itself. We are using GitLab, open source version, not enterprise. And what they said is use a push mechanism. No need for pull mechanism via any tools. Rather go by just GitLab runner. So that is also possible.
You have to manage the CD flow with the GitLab. So any failures, you'll have to debug it there. So then you're not using the Gitops model at all, right?
So that's not a Gitops model, right?
That's not the Gitops model.
So it's still a traditional CI/CD flow for GitLab
approach. So we just discussed about that disadvantage of using the CI/CD, right? See, it is more error prone. If there are any problem, you'll have to fix it yourself. So you'll have to debug why it failed. But when using a Gitops, you have a lot of advantages. So visualization is one of them, but the chances of the release is quick, and then the chances of error is very less. And then you have versioning control as well, since it is based on the Git. So you can do an easy rollback, and versioning is easy. But as I told, we need not have all the tools that we have discussed in this session. So in the last 6 weeks, we have discussed multiple tools, right? So we need not have all these tools deployed into your cluster. So why? Because if you deploy an Argo CD in the cluster, then you'll have to have the operation team taking care of the Argo CD upgrade and then managing the Argo CD. But if you're building a very small cluster, like 4 or 5 nodes at the initial and as a POC, this is not needed. But as you go in an enterprise scale level, you must have a Gitops tool. So that's how these tools are fitting in that place, and that's why it is getting popular. So it's not based on the small startup which is exploring the setup of having the Kubernetes environment. Maybe that time it might not be that much useful, but I would eventually say we should explore having an Argo CD. I don't see any disadvantage of using Argo CD because that is meant to be a CD tool for your cluster. So you'll have to always consider using that. Yeah. So it is based on your architect design of your cluster. So yeah, but still you should give it a go on the Argo CD because it can pick up the changes from the GitLab as well. So all that you need is authentication mechanism to the Git. That's it. Okay. Yep. So moving on. Let's see the components. Yep. So we have discussed the UI, and then it can be integrated to any monitoring tools like Prometheus and Grafana. If Argo CD itself is having a problem, like it is not working, it's not syncing your source from the Git. So all these has to be investigated. So Argo CD itself is a set of workloads that's running. So you'll have to investigate which component is failing. So then you need a monitoring. So this can be integrated with your Prometheus, Grafana, REFK stack, or whatever monitoring that you are using in your cluster, like Dynatrace or Datadog. So all these tools can be visualized for any errors. Like you can visualize the metrics, you can visualize all the logs with respect to the Argo CD configuration, and then investigate. So you get a monitoring support for Argo CD. And then, as I told, you don't need to have for every cluster, you don't need to have one Argo CD deployed. So I have 3 clusters, okay, and I don't need 3 Argo CD at all. So all that I can do is I can configure Argo CD in one cluster and then use other clusters. So just configure additional clusters onto the the Argo CD that we are deploying. So have one Argo CD and then manage all the clusters. So yeah, with that, you don't need to install the Argo CD in all the places. For example, I have multiple environments like dev, test, staging, and the production. Or else if I have multiple region as well, like West Europe, US, and Southeast Asia, if I consider all these three regions, then still you can have a single Argo CD and then manage all the clusters centrally from one place. So that's the advantage of using Argo CD. So you don't need to manage Argo CD on all the clusters. So just manage it centrally for you, for your organization, and then have multi-cluster support. So that's one thing. And then it works with Helm and Customize. So let's see what is Customize in brief, and then let's see how, if we can cover it, or I will give a lab assignment for Customize. But we know well how the Helm works, right? So it can work with Helm and Customize. Okay. So that's the advantage of using Argo CD. So as we have already discussed, what is the flow of Argo CD? Okay, any developer, they do a commit on the Git, and then it will check for the changes. Like Argo CD continuously polls the Git repository that you have configured. So by default, it just checks for every 3 minutes. Okay, this can be reconfigured as well. If you are doing a lot of changes for every 1 minute also, you can reconfigure it. Or if it is, you're not doing that many changes, then you can reconfigure this interval to 10 minutes. So every 10 minutes, it can check your Git repository. And if there are any changes from the last synced state, it will check the changes and then it will sync. So that's how it works. So it is not actually based on the commit. It is actually based on the polling interval that is configured. So you can also do an event based, like if there is a commit, then also it can initiate the Argo CD sync. So 2 ways, pull and push based, both is supported. Okay. So the Argo CD, it just watches the Git, and then it checks if we did any change in the manifest or any change in the Helm release version, and then it will check the state. So it compares the state with the Kubernetes manifest that we have. So it checks if there are any changes to the current state. So, and then if there are any differences, it will sync that state to the cluster. So if there are no changes in the manifest, then it will not do anything. So it just checks that there is no diff detected, and then it does not sync at all. Okay. Yeah. Any questions? Okay. So let's move on to the Argo CD architecture. So any tool, if you install, there will be an architecture behind the scenes, and then you will have to deploy some these Argo CD tools in a specific namespace, and then that namespace will have all these components installed by default. So if you do an Helm install Argo CD from the Argo CD repo, all these tools will be installed. Okay. So the flow will get inside the flow. And then so you have a Argo CD server. So this is your Argo CD server. So this Argo CD server, which is exposed by your UI component. So we will see all the UI by connecting to the Argo CD server. So basically, this Argo CD server is your
we are not able to see the slide. We can see draw.type.
What you're seeing?
Draw.type.
Okay, let me reshare. Thanks for the notification. Do you see the presentation now?
Yes.
Okay. Yeah. So we have the Argo CD server. So this is where we will have an UI. Okay, so this we are connecting to the Argo CD server. Consider this as an API server in Kubernetes. So basically, you will do all the CLI UI actions by connecting to this Argo CD server component. So basically, what it does, it just does all the application management and status reporting. So it invokes any application operations, like if we do any sync, rollback, or any user-defined action, So this server will come into picture, and then this will perform all the actions. Okay. So this will not do a direct action, but it will instruct a repo server to do its responsible actions. So let's see what repo server and application controller, application set controller does. Yeah. So basically, what do you need to access the Argo CD API server? You need authentication mechanism. So once you are authorized, then you will log into the Argo CD server. So basically, you can configure SSO by integrating with your Azure AD or IAM. So you can configure RBAC mechanism. So for example, if you have cluster admins, they should have full access to all the Argo CD projects, all the clusters, right? So you'll have to configure RBAC in such a way that whether the cluster admin is logged into the Argo, and then they will have to see all the resources. So in such a way that you have to configure the RBAC. So you can also give an Argo CD access to the application teams, but only to their respective namespace. So in that case, you will have to define the RBAC by configuring the right roles to them. Okay, so for example, if they have dev namespace, only dev team needs access. So your RBAC should be configured in such a way that only they can see the dev team namespace. Or in Argo CD world, how the RBAC works, it's basically a dev project. So they say project in Argo CD. So project means a specific place where all their applications will be deployed. So basically, you'll have to restrict the access to their project. So dev project, and then staging project, and then production project. So you can segregate based on the teams or else based on the environment. So that's how you will do an RBAC. The RBAC, everything will be handled by the API server. Okay. So let's move on to the repository server. So what this repository server, as per the name says, it is going to maintain your local cache. So it is going to take your Git repository manifest and maintain a local cache, and then it just deploys that into your cluster. So basically, what this repository server will have, the repository URL, and then the revision tag or branch details, how we are defining for an application to sync, and then path inside this repository. So you can sync the entire repository, or you can sync only specific path. Because, for example, if you see this lab structure itself, we have week 1, week 2, week 3. So you can specifically sync week 6 and then sync only the files that are available inside week 6. So you can configure repository path, and then revision is based on whether a commit or tag or branch. So based on that, it is going to sync the manifest. Okay. So it can directly sync all the all the YAMLs that are there, similar to our kubectl. So how we applied the kubectl apply all manifest, it can either do that way, or else if you have Helm chart, it is recognizing itself, and then it will deploy based on your values.yaml. So we are going to see everything in the demo today, and then explore all the options that are available. Okay. So that's your repo server. And the application controller, it monitors so basically this is the controller which just checks the state of your Kubernetes cluster, and then what you have in the repository. So basically this repo server is going to cache it in the Redis cache. So all the manifests that are there in the Git repo will have a copy in the Redis cache, and then this cache will be refreshed every few times. So you will have a configuration that it will refresh maybe every 1 hour or 2 hours. So it's going to refresh all the configurations. So basically this application controller, what it does, it just checks the state from Kubernetes and from your Git repository. So it compares, and if there is any difference, then what it will happen, it will immediately makes your application, Argo CD application, out of sync. So which means there are some application that is out of sync, and then this needs a immediate sync to correct the out of sync status. So then First thing is what it will do, it will check the Kubernetes cluster and take the state, and then it will check the manifest in the cache, and then it compares both the states. So you have two set of YAMLs now, and then it compares if there are any changes or drifts identified. Immediately your Argo CD application will go in out of sync state. So out of sync means what will happen? So in the next sync cycle, in next 3 minutes, it will perform a sync for the out of sync application. So that's how your this application controller will work. Okay. Yeah. So application set controller is another thing. So it's similar to application controller. So instead what it does, it just creates multiple applications. So just don't get into deep on the application set controller. Basically, it as from the name, you are seeing that application set controller creates multiple application. Again, application controller. So once you have an application, then application controller will come into picture, compares the state, and then makes the out of sync state if there are any drift. And then to correct the out of sync state, you will have a sync cycle to perform the sync to the latest version. Okay. Any doubt in the architecture? Yeah. Okay. So let's move forward. So let's see, imagine where this Gitops will fit into picture, like in the CI/CD world. So it is not going to touch any of your CI2. So CI is still going to run as usual. So we are just cutting down the CD part, and then you don't need to configure anything in the CI/CD pipeline at all. So all that you'll have to do is you'll have to push the manifest, this. So maybe you can have an additional configuration to push it to the Git repository. So that's it. So that Git repository will be watched by your Argo CD, and then it will sync to your Kubernetes cluster. That's it. So that is where this CI/CD workflow will be there with Argo CD. Okay. So I think we have already seen the use of it. Yeah. I think we have covered the component, but let's see what we missed. Yeah. So we have Argo CD repo server, which is going to check the manifest and create a cache of it. And API server, that is where all your UI is going to interact, CLI is going to interact. You can do a REST-based calls as well. So all these things is going to connect to your API server. Okay. So basically, all the connectivity happens to this API server. So we are not going to connect to the repository server or application controller directly. So it goes through from your API server. So it's similar to your Kubernetes API server, you can consider. Okay. And then there are a lot of things and hooks. So you can integrate with any other tools as well. Yeah. And then you can deploy it to, so multi-cluster. So this comes in multi-cluster. You can deploy it into multiple clusters. So with one Argo CD, you just configure the destination as multiple different clusters. So based on the destination only, it is going to sync. So if my destination is local cluster, it's going to sync where the Argo CD is installed. But if your destination is remote server, so dev staging cluster, then it is going to sync to that other destination cluster. So this is how this multi-cluster will work. Okay. And then as soon as you do a PR merge to your Git, and then immediately a webhook event will take place, and then all the cycle will be started. Okay. Now, any query? Okay. My screen is still visible, right? Just to ensure.
Yes, yes.
Now, fine. I was keep repeating the word sync. It syncs, right? So there are different types of syncs available, manual or automatic. So basically, we prefer to have automatic sync because whenever there is any commit happening, so what it will do, immediately your Argo CD will check for any drift, and then if there are any drift, it will be marked as out of sync, and immediately in the next sync cycle, it will be synced to your cluster. So that's the major advantage of using automated sync. So either when you deploy any application, you can configure as automatic or manual. So these two has its own advantage. Like it can have faster deployments, and then you can ensure that your cluster is always in sync. So that's the advantage of using automatic sync. But what is the risk of it? So it is going to sync everything, right? So it's not going to validate if you're doing any right thing, or you just do an incorrect configuration or incorrect image. Then it is going to sync, and then your application will be down, right? So that is so this faster mechanism does not work always for a production environment. So in the production environment, people will stop the automated sync and then have it with manual sync policy. So to avoid any unintentional changes, or to avoid any misconfiguration, we don't set this automated sync. So in that case, what we'll have to prefer, we'll have to have manual sync policy. So what it will do in case of manual sync, it is still going to compare your live state and the production state, and then it will mark the application status in out of sync status. So it will still be reporting as out of sync until you open the Argo CD UI and then click on sync. Then only the sync will happen. So it is going to check the drift anyways behind the scenes, and then it is going to project out of sync status. So that is up to that, the concept is same in both the flow. So to remediate the out of sync, whether it is automated or manual, that is the place that we are configuring this. Okay. So these are the two sync policies that we have. So it's safer mainly for production environment, and the other pro is any accidental changes can be visualized very easily, and then we will have people monitoring until you do a sync, and then they can check an action and then do a rollback immediately if there are any problem with the deployment. So this is the advantage of using manual sync. And of course, the con is it needs a human intervention, and it is going to be slower. It's not rapid like your automated sync. Okay. Yeah. So that's the use case as well. So manual for critical and production environment where you need a human intervention, and then where you need human approvals. So that's where this manual sync will come into picture. And then automated sync for non-prod environments, or even for the production environment, this is being configured. But all that you'll have to do is, if there are out of sync, if there are any application, Argo application failing, then what you will have to do, you will have to create an alerting mechanism. If an application fails with the automated sync, then you'll have to have an alert. So immediately trigger an alert to the team. Then this application is down. Then people have to come in and fix the issue. So both the ways are possible for production approach. Based on the strategy that people will choose, this will be configured. So there is no hard rule that we'll have to set it manual or automated. So it's all based on the strategy that you are choosing. Yeah. I think we have covered most of it already. So Argo CD server is the UI. And then, so basically that is your API server. And then you can accept the rollback options as well. So if there are any problem, what's the maximum human intervention is needed is just click on the rollback to previous version. So it is going to revert to the previous release or the previous commit that is being done. So it's going to roll back. So with single click, your application will be up, and you don't need an application team at all to fix that, right? So you can do it by yourself. Yeah. The repo server, we have discussed it already. Basically, it fetches the manifest and then keeps it in the cache. So why this manifest fetching is required? To compare the changes to the Kubernetes cluster. And then application controller, this is where this reconciliation will happen. So it checks out of sync status, right? So immediately it has to go for sync. So every 3-minute interval, sync trigger will happen. So that is a reconciliation engine. So it reconciles for every 3 minutes. Okay. Redis is for caching the manifest. So every time you don't need to pull all the manifests that are available in the Git repository, right? So what you can do, you can cache the manifest locally and then check the caching. So if there are any problem with the cached data, what it will check, it will have a frequent cycle for caching as well. It will clear the cache and then it will fetch the fresh application set, application manifest. So with that, your application will not have Argo CD application will not have huge load because it's managing a cache. And if the cache expires, it will pull the latest data. So yeah, so that's the use of caching. So we have additional component called DEX is mainly for SSO authentication. So you can integrate DEX with your OIDC providing partners, like you can integrate Google or Azure AD, or, yeah, even Facebook. So how you log into other applications, like if I am logging into some Instagram or some application, either you can also choose Google as your provider, right? So using your Google account, you can log into various applications. So that is going to be my SSO configuration. So every time when I log in, I don't need to create a login credential. All that you'll have to integrate with the providers and then just authenticate with the same ID. So that is the use of DEX. So you can configure the identity providers in DEX for SSO. Yeah. Okay. Again, we have multiple ways to create an Argo application. So from UI, we can create. So log into Argo CD URL, create an Argo CD application. Or else you have CLI. So Argo CD, you have a CLI like Helm, like Kubectl. You have a CLI and then Argo CD log in to the server with username and password and then create an application from the CLI itself. Argo CD create application and then all the configuration you have to give it in the CLI and then it is going to create a Argo CD application. Okay. So these are the ways to create. Yeah. And I think we have spoke about the rollback. So I just want to reiterate on the different rollback strategies. Like even Kubectl command has a rollback mechanism, right? So Kubectl will also do a rollback. So there is an option to roll back from the Kubectl command. Kubectl rollback and your deployment name. So it will roll back to the previous version. So how it is managed? It's managed using the replica set. So for each and every deployment, it will have a respective replica set mapped. So by default, it is not going to, when you create a new deployment, it is going to map the previous replica set in the history. So if you do any rollback, it will pick up the previous replica set, which is available. So basically, I think by default, it will manage 5 different replica set versions. So you can do a rollback up to these 5 versions. Okay. So this is the command, rollout undo to previous deployments. So you'll have to mention the history number to roll back to the right version. But what is the problem with this? It is going to roll back only the deployment. It's not going to roll back the service. It's not going to roll back the ingress. So if you do any changes to your ingress or to your service where you change the labels or ports, it is not going to work, right? So you have the mechanism only to roll back the pods. So not for the entire set of manifests. So you know all the manifests required, right? So for example, deployment, service, HPA, ingress and volumes, config map, secrets, all these files are combined to form a release, right? So your Kubectl is not going to roll back all of these files. It's only going to roll back the deployment file, which is not feasible, right? So which is not going to work if they are doing changes. If there are manual changes that are being done, it's not going to roll back. But with Argo CD, it is version controlled as we are using Git as a source of truth. So Git will have history of all the commits or tags or based on the branches, it will manage the versions. So when you do a rollback, the entire, how it will be rolled back, Argo CD app rollback, or in UI, you can just click on the Argo application and then you do a rollback. So if you do this rollback, it works for the entire application. So all the YAML manifest, which I called out now, it is going to roll back to the previous version. So wherever you did the changes, or you have not done the changes, it's going to roll back to the previous version completely. Okay. Yeah. So that's the advantage of using Argo CD rollback. So you don't need to rely on anybody to do this rollback. You can do it yourself. So it yeah, that's so resilient. So you can manage the errors yourself without calling any of the application teams in case of any production outage or something. Or if there are any new release plan, you don't need always the application to be in call, right? So in case of a production rollout with CI/CD, if there are any problem, so you will have to have a application team with you to define the rollback mechanism, and then you'll have to run the rollback pipeline and then do the complete the release. So you'll have to involve them. But in case of Argo CD, if your previous application was working fine, then you can roll back to the previous version without involving them. And then you can just report that the new release did not work. So they will get enough time to fix them. Yeah. So that's how, so it's so easy to manage the applications in production. Yeah. In terms of security and SSO, so each and every tool that we have seen so far will have an inbuilt security mechanism and then SSO for single sign-on. So for that, you can either use local users. For example, I can configure admin and then admin at 123. That's my password. So basically, you can configure local users or you can configure SSO. So you can integrate OIDC. So as I said, you need a mechanism to integrate the OIDC, right? Single sign-on. So either you can integrate it with GitHub, Google provider, or Azure AD provider. Then you can do SSO. So how SSO will work in Argo CD? It has an inbuilt component called Dex server. It is going to authenticate using the SSO. For example, if your Dex server is down, your SSO might not work. Argo CD will still be up because your Argo server is up, but your Dex is down, then your SSO will not work. In such case, you'll have to use the admin or local user, whatever you have configured. Then you have to use that ID and then log in to your Argo CD. But mainly you'll have to fix the Dex server if it is down. Yeah. Right. So just we will understand these sync wave concept, and then let's see in the demo how we can cover it in the live production application deployment. Yeah.
So cluster itself also provides OIDC, Kubernetes cluster.
Yes. So in the cluster itself, there is a Kube OIDC application. So basically, this Dex does not need to have a separate OIDC, Kube OIDC at all. So you can just integrate Dex, and all that you'll have to give is the client ID and the client secret to authenticate using that provider, and then it is going to log in. So you don't need a Kube OIDC, but for other tools, you might have to integrate with Kube OIDC. So even though Kube OIDC deployment you do, but still you need a client ID and a client secret to authenticate, right? So still, even if you use the Kube OIDC, you still need to configure the credentials somewhere. So you don't need to have a Kube OIDC at all. So Dex will take care for us. Okay, but some of the application needs Kube OIDC to authenticate. I think Falco, all these tools require Kube OIDC to log in. So you have to integrate with Kube OIDC and then log in. But it's not necessary that all the tools are has a requirement of having a Kube OIDC. So it's all that it does integrates with some tools and then just configure CI/CD, client ID, client secret, and then authenticate to the application. That's it. Did it clear?
Yes, yes.
Okay. Yes. So there are different roles available, like user is, I am the user, and then who is the client? Argo CD is my client. Identity provider for in terms of SSO, either Google or Azure AD is my identity provider. And the OADC protocol is the language that is used to talk securely. So in our case, DEX is the OADC protocol, but Cube OADC is another tool that you deployed in the cluster itself. Basically, I think it goes by default in Cube system namespace, if I'm not wrong, or you can reconfigure it to other Cube security namespace and then have that call this Cube OADC in case of any OADC authentication for some tools, and then you can reconfigure your SSO. Okay. Yeah. So before OADC, what you need? Before OADC, you need your own login, and you have to store the password in some secure places, and that's hard to manage. So with OADC, we definitely have a single sign-on and centrally managed identities, which is more secure, right? And then integrating your RBAC is more easier with OADC instead of managing for specific users. For dev team, you don't need to have a specific user created in Argo CD, but even that local user creation is also possible. Okay. So yeah, 2 ways to authenticate. So for authentication, and authentication is one thing. So you just logged in, but what you see after you log in comes in authorization. So how that works? So with OADC, what we do is authenticate. Who are you? So for that only, you're integrating with Azure AD. If you are really a part of an organization member, then you will be authenticated. So that's why it is integrating with the identity providers. So allowed identity provider is Azure Azure AD means only members in Azure AD will be allowed to log in. So that's your authentication. So do all the authenticated user need to check all of these things? No, right? So there comes in additional thing called authorization. So what you can access? Can you access all the application? Can you access all the projects? Can you access all the cluster? No, right? That you will have to define. So you'll have to have something called as policy. So for example, any particular user, if they are part of any group, then you will have to assign the right policy, like dev user. So for belongs to the dev group, they should have authorization only to view dev project or dev cluster. So how you are configuring your application or cluster in the Argo CD, then based on that, you will have to have the RBAC assigned for them. Okay. Yeah, any question? Right. So moving on to the sync ways. So you have just a recall for the manifest. Can you recall all the application manifest which are required to onboard an application? Can someone recall? What are the applications that are required?
Namespace,
Namespace, yeah,
config map, secrets, RBAC, PVPVC, HPA, deployment, service, gateway class, gateway, virtual service if it is like Istio, otherwise it's a HTTP route.
Superb. So initial class, I remember that you were saying namespace, deployment, and service. So now how many you have added, right? So for each and every solution, you are adding one file. So that's why we are seeing 10 manifest, which is very good. So you said 10 application manifest, like the Kubernetes manifest, right? So out of which, what do you think that what has to be created first? Any
Namespace.
Namespace, yes. After that,
Secrets, config maps,
mm-hmm.
and then
RBAC.
PVC
Okay.
and service,
Mm-hmm.
ingress HTTP route,
Mm-hmm.
API class.
Okay. So let me ask you a question then. So I have a namespace. Okay. So then my deployment is getting created. Okay, and it is failing. So what
Okay.
could be the reason for the deployment failure?
Maybe dependent resources are in conflict. Not config map not available, which is required for
Yeah.
deployment.
Config map is
Secrets.
dependent resource. What are the other dependent resource?
Storage.
Exactly. So your storage class has to be up. If you are creating a storage class, it has to be up. So, but if you are using a PVC, it has to create a persistence volume behind the scenes. So this is the dependent flow. So your dependent flow is not with the service. Service is not having any dependency. And even your config map and secret is also not having any dependency. So it is a independent resource, I would say. So maybe it is dependent for deployment, but it's not going to, this config map and secret is not going to check something else as well to make a delay there. So it's not going to check some external resource, right? So it's just an YAML file, it's going to create. That's it. Okay. But if you don't have the key in the config map, if you don't have the secret in the config map, then it is another problem. It's the application issue. It's not the dependency issue, right? So then the service, config map, RBACs, everything is ruled out, right? So what are the dependent resource now? The deployment is dependent on volume, right? The PVC is the dependent resource here, okay? And then your ingress class should not be created before your deployment, right? So it will fail. So ingress might fail, right? So then in that case, so it is dependent on your deployment, right? But as soon as your deployment is up, your ingress will be working. So a highly dependent resource is volume in this case. So then what you need to,
service account as well, right? If we mention the service account in the spec of the container,
but when you do a kubectl apply, how long the service account can wait to create? It's going to create immediately, right? It's not going to wait for something. It's going to create just in a fraction of a second, because service account is not dependent on anything else. Service account is not provisioning anything, right? But when you're PVC, you're creating, it is dependent on few things. Like it is dependent on storage class. It is going to create a volume. If there are any problem with the volume creation, your deployment will fail, right? So that's dependent. So,
but we need to apply the service account and PVC YAML files before applying the deployment YAML file, right?
not necessarily. Not necessarily. So when you do a kubectl apply, so I will say when you do a kubectl apply, it is going to deploy, it is going to give kubectl applied, service account created, and the namespace created, rollback created, deployment created, right? So, but when you create a service account, it is immediately it's going to create. It's not going to have a delay at all. That's what I'm saying. But
I understood that, but my question was if we are applying kubectl apply separately for each YAML files. So first, initially we have to apply the PVC volume YAML file and service account YAML file. Then we have to apply the deployment YAML file, right?
exactly. But do you think that you will apply single file?
No. We'll
Yeah,
not
but for your question, yes, that is going to be a problem. So if you're just creating a deployment, the deployment has a service account pointing to a specific service account. If that service account is missing, if that config map, that deployment referring is missing, then it will fail, because it will show config map not found, service account not found, secret not found. So all these things will fail. So what we are talking here about is when you deploy all the resource at once. So we are deploying all these manifest at once. So there need to be an order, right? Order of a deployment. So that is achieved using sync waves. So sync waves is a numeric pattern, like from starting from -0 and then plus. So that is the order of sync wave. So whichever you're giving -1, that takes precedence. So that will be created first. And then if you don't mention anything, that comes into default sync wave. So all the files can be deployed parallelly. So there is no dependency. So why I'm talking about here this thing? Because your namespace need to be created before even creating a service account in that namespace, right? For a namespace can be in the sync wave -1, and then your persistence volume claim can also sit in -1. So you don't need to manage very complex like -2, -3 and all. So just to maintain -1. So -1 means those resources will be first created. So once these resources are created, if namespace is created, persistent volume claim is created, then comes with the sync wave 0. 0 means if you don't mention anything, it will fall under default sync wave. All the other files like configuration map, secret, RBAC, everything will be deployed in parallel because they don't have any dependency. So basically it is task order, the order of the application deployment. Yeah. Do you understand what I mean here in the sync wave?
Yes, sir.
Oh, thank you. So that's basically nothing but order of your deployment. So you can completely avoid this sync wave concept at all. So maybe after 6 months, you will face an issue. Like immediately, if you do any deployment, it might fail for some time unless your TVC is created. Then if it is created, it's going to work. But that for that fraction of second, your application will be down. For that reason, we need to manage this sync wave. So it's not going to be your day one operation. So in day 2, you will see all these issues and then you will correct all these things in the future. So it's not going to be on the day where you install Argo CD. So it's going to be on the production application. Maybe for after 6 months, if you're seeing this problem quite often, then consider setting these sync waves and hooks also. So after this deployment, perform other actions like before, after, during the deployment. So if it performs something like cleaning up few volumes or cleaning up few jobs, if there are any dependent jobs that runs after your application is deployed, so those things can be configured in the hooks. And the pruning is nothing but cleaning. So Argo CD is so powerful. It is going, if you set the automated sync, it is going to create the resource. But if you by mistake you delete a manifest in the cluster and you do a commit immediately, it is going to delete all the resource. So for example, I have a week 6, right? Yeah. So I have, if you see here, I have wcaps week 6, right? And then I was reworking on these files. So by mistake, I've just configured as week 6 in small letter, like just change the folder structure or change anything. Then if I do a commit, if I have an Argo CD application watching this repository, it will immediately throw an out of sync and then immediately start deleting the files. First it goes for the deletion. It's not going to create a new file and then it is going to delete, nothing like that. So it's going to delete all my files and then resync it with week 6. Okay, not from the camel case, right? So that is what we have to control, right? So any accidental deletions, how your deletion should be treated. If I delete, should I delete all the resources immediately? Or then if you prune false, then the resources will still be there, but your Argo CD application will be recreated. That's it. So resource, underlying application resource, Kubernetes manifest will not be touched in the Kubernetes cluster. Got my point? What's prune? Prune is nothing but how to manage your deletions. So if you accidentally delete a Kubernetes manifest from the repository, if you don't set any prune option, it is going to delete all the manifest from your cluster, which means your application will be deleted from the cluster and then new application will be synced. So the intention is just to do a upgrade of the application. But see what destruction it created, it deleted and then recreated. So to manage the safer deletion, we have a concept called as prune management. So in case of such deletion, whether a resource should be retained or deleted. So that need to be configured using these prune settings. So basically it comes in when we handle the deletion scenario. Let's see with the demo how we can configure different prune settings. Okay, and self-healing, I think we have spoken a lot about it. If there is a drift, it checks the drift and the reports are out of sync, and then it fixes the drift in the next cycle automatically without any action. Okay, so that's the detail of all the options that we have with the sync base. Okay, yeah, and you can add multiple clusters. You can just have one Argo CD cluster and then add remote clusters to it, and then manage all the clusters through the single Argo CD, which is a centralized Argo CD configuration for your organization, where you will have hundreds of clusters as well and managing it. So basically how a rancher does, a rancher manages multiple clusters, right? So similarly, this Argo CD is going to do a rollout on all the remote clusters where you have added. So if you add a remote cluster, then it will be managed from here. So all that you'll have to mention is which application goes where. That's it. In the application configuration, you'll have to mention the destination cluster. So based on the destination cluster, it is going to sync your application onto the destination cluster. How a cluster will be added? Basically, you need a kubeconfig to be authenticated. So you will have to have authentication between the Argo CD and the cluster, then only it will work. So you'll have to authenticate and then add the cluster, then configure the cluster in your application. That's it. Again, I think we have seen this already. So you can have metrics, you can have alerts. So if any application fails, if it is a critical application, you should have an alert, right? So you can configure an alerting mechanism from the monitoring tool and send it to your Slack or Teams or even you can integrate PagerDuty and then have a call. So if there is any downtime in your application, it will be immediately notified and then you can act on the alert. Yeah, I think you can integrate with monitoring tools. You have the logs for debugging and you can have the application health check. You can have a dashboard in the Grafana. Check all the application status. If there are applications that are in out of sync or failed state, so all these things can be handled here. Yes.
Will this process help for an platform which needs to maintain uptime or availability on 3 nines, which is nothing but 15 minutes a year, right? I mean 4 nines or 3 nines, I'm not sure, but let's say I have only 15 minutes per year to take a maintenance for a particular platform.
Okay.
Then these kind of practices is going to be a benefit or
so basically
overcomplicate.
So uptime will not be measured from Argo CD. So basically, I think you are asking about the SLO and the SLI or SLA. So
let's say SLO, right? So SLO availability on the platform level availability.
Argo CD dashboard is only for your Argo CD uptime. So for your SLO or SLI for your entire cluster, you have to build your own SLO mechanism and then check all the application, all the cluster availability, application availability. So you'll have to have a separate mechanism for managing the uptime. Okay.
Yes. We sorry to interrupt. Actually, maybe I'll rephrase my question. Let's say I have all the SLO calculations in a separate tool. That's all fine. My question was, this Gitops methodology or a practice is going to help me to improve my overall platform uptime.
Definitely, yes. Yes, because if you are managing your CI/CD separately, and then it involves a lot of interventions, human intervention, then 15 minutes will be gone, just like that, right? But with Argo CD, you will have a mechanism of rolling out or rolling back to the previous version. With that, it means that your application, chances of your application going down is less. In that case, yes. So not for the cluster availability, but for your application availability, this will definitely help in the long run.
Yes, thanks.
Right. So moving on to the rollouts. So this Argo CD itself So they claim it as progressive delivery. So how you can configure two, I think I don't want to answer it. I want to ask question. So what is blue-green deployment? Okay. Yeah, Poluka, you.
Deploying two different versions, like at a time exposing one version of it.
Okay.
Like weightage will be 100 is to 0.
Right. So managing two versions at the same time. So basically 100% of your traffic will go to blue deployment or a green deployment. So you'll have a standby application running all the time. So if in case of any problem, you will just roll to the other version, move the traffic, all the traffic to the other version, which is at the standby. That's the blue-green deployment. I think we also have Raj in the call, right? Raj, can you tell me what is canary deployment? Don't mind if you don't know also, but just try.
Ma'am, Canary is all about we have a 10% of the new version and a 90% of the older version. Gradually, we are increasing the new version based on the traffic.
Exactly, very good. Yeah. So canary, I think we are following all the sessions quite good. Yeah, which is good. So basically, this Argo CD can manage blue-green rollouts or canary rollouts easily by out of the box. It is giving all these features. And then as the name suggests, it's going to be a progressive delivery. So you can increase the traffic. So either you can increase 100% of traffic in case of blue-green deployment to two different versions. That is possible. So all with just one click. Okay. Or canary also you can promote the deployment. So 10% today, 20, the day after tomorrow, 30, 40, 50, 100%. And then make the other also 0%. That's also possible. So the progressive delivery, we can do it. And Gitops for microservices. Anyways, all the changes will be synced immediately, right? So it's good. That's what the Gitops model is, right? So Argo CD is 100% in line with the Gitops approach. Yeah, that's it on the Argo CD slides. Let's move into the demo. Any question? I think if no, can someone be volunteer today to help me with the Argo demo? Hello? Any volunteer? Okay. Are we not following? Or you don't have your system ready?
Okay, I will go.
This is a traveling weekend, right? Probably people might have joined through mobile. Actually,
No,
I was planning to do it. That's why I asked what setup needs to be done, but unfortunately, I couldn't carry my laptop.
So no worries. Then I will do it on myself this week. But next session onwards, I want some volunteers. So that because when you do the lab, you will raise questions like why we are doing this. So that's why I always need a volunteer. Okay. Don't mind.
Can I go ahead?
Yes, please.
We just.
So this week's session is week 6. You have the repository already, right?
Yes.
Okay. So let me unshare my screen. You can share. I think from next session onwards, I want the volunteers to be from other people, like Abhishek. Yeah, Sanam Indrajit. Yeah, you can also volunteer. So if you have any doubts, I will definitely help you. And as a backup, I have my machine ready to cover if something is not working. Yeah, so no worries. Don't mind. And also, even if it is simple query, I think I want you all to raise your voice and then ask questions. I don't mind repeating the same thing again and again. Yeah. So week 6. So today we are running week 6.
I have a cluster already.
Okay. So you can skip this SSO. Let's do it later. Yes, skip this as well. No worries. Skip this as well. Come down. Yeah, go to the port forward directly.
So actually, I'm running from my EC2 instance. That's why I'm doing port forwarding. Yeah.
Okay, no worries.
Now, can I open the UI?
Yes. So on the other window, run this.
I think something else is running. I will do this on some other tool.
I think meantime you fix this issue. Let me ask some questions to some of the members.
Okay.
Yeah, so that we keep them engaging as well. Indrajit, can you tell other Gitops tools that is famously available? Hello? Indrajit, are you active in the session?
Yeah.
Yeah?
Yes.
Okay.
Yes.
So you first of all, you don't mind, right?
Yes.
I have
No.
questions. Yeah. So yes. So I'm going to do a summarization of Argo CD. So because
Yes.
we are not going to repeat this in any of the sessions, so that's why I'm just I just want to keep repeating the terminologies until you understand it or you remember it.
Other means, ma'am, Flex CD or Jenkins.
Yeah.
Can-
Okay. So but Jenkins will not come into the Gitops. So it's basically a CI/CD tool. Okay, your Azure DevOps or your Bamboo or yeah, Jenkins will come in the other side. So it's basically comes into the CI/CD tool. So DevOps, in DevOps we will get to understand the CI/CD. So that is where those tools will come into picture. But you are right, for the Flux CD and Argo CD, so these are GitOps tools. Okay. So just be clear in answering these questions in interviews. Okay.
Yes.
So yeah, so this will be a blunder. So if you compare Argo CD with other tools like your Jenkins or DevOps tools like GitLab or GitHub Actions, then it's not same, right? So this is specifically running inside your Kubernetes cluster. So specifically designed for CD for Kubernetes. Okay. Yeah.
Yes.
So don't mind if I correct, but what you said is on the same line, it's correct. But still, I want you to be more specifically answer these questions. Okay.
Yeah. Sure.
So let's move on to the Argo CD architecture. So can you name the components which are there for Argo CD? Just name one or two, that's enough. Like in the Argo CD architecture, you have seen some flow diagrams in my machine, right? Some time back.
Yes.
Try to recall it.
Repo server, controller,
Hmm.
Yeah.
Wow, that's good.
application
Yes.
controller. application set controller.
Yes, exactly. So just to re-summarize, so we have repo server to check the Git and check all the Git source of truth, and then it will have a cache. So you will definitely see a cache pod when you deploy Argo CD. It's going to cache the manifest locally in the Argo CD itself, just to avoid huge application sync and then to avoid the Argo load. So yeah, so that is the use of Redis cache and repo server. So what other component you said? Server, right? Server is your API server. Consider that as a API server. API server means all your calls will come into API server. So whenever you access Argo CD UI or Argo CD using CLI, all these calls will go to server. So I think we have done the port forward as well. So if you see the port forward command, it is going to be a server, Argo server. So that is where your UI is going to interact. So that is where you are going to do a port forward and all. So yeah. So application controller. So that is going to compare all your state of your application. So what's there in the cluster, what's there in the Git repo. So just going to compare and then project a status like out of sync, or if it is in sync, it is going to give you the green tick. It is in sync. If not, yellow tick. Yellow color means out of sync. Red means failed. So all the three status you can see. Okay. So out of sync, it will try to sync. If it fails, and then it will be in failed status. So that is where your application controller will come into picture. Okay. So now can you repeat, Indrajit, what are these components that I just said? Just want to reiterate.
API server, ma'am, repo server, and application controller.
Exactly. And Redis cache also.
Redis and okay.
So another component which is missed.
Good morning.
Ma'am, few minutes I will not available due to stand up. Sorry for that.
Okay, no worries. Abhishek, can you unmute yourself? So what
Yeah.
other component that we just discussed? I think you missed one other component.
Yeah, I miss Redis cache memory.
Redis cache. Another component that you missed. What is that?
Uh,
For authentication. Just giving a tip. For
Yes.
authentication, what pod you will see?
Dex,
Exactly. So Dex is for what?
OIDC in authentication. For
Exactly. So how do you integrate OIDC to which providers?
Single sign-on.
Single sign-on with what? So you
Azure
need to
AD
have
and
single sign-on with some providers, right?
yeah, Azure AD.
Azure AD.
Yeah.
Or just
Yeah, you
for the demo purpose, we are going to do
Google.
Google providers. Can integrate with your Gmail also, right? And then authenticate your application. So multiple ways to integrate OIDC. Because if you see any internet based application, like any apps that you deploy, or if you access any URLs which needs an authentication, right? So they have integrated Google or Facebook or Instagram. So these IDs they have integrated in their identity providers. So we are just making use of the same ID and then authorizing it. So the list of providers that it is going to provide, so they have configured it in their application. So why did not, so not all of them do a Facebook based authentication, right? Facebook is not an identity provider, but your Google account, Google provider is allowed in most of the application, right? So that's basically for your professional service, right? So that's the reason why your Google providers you are seeing in multiple applications. So similarly, Argo CD, we are integrating with identity provider, which is Google or Azure AD. So if in the production case, it is going to be your Azure AD. But for if you're doing some tests, you can integrate other providers as well. Yes. Is it working? Yeah. Who is sharing? Is it Polika or Swarna?
Me, Polika. So username, what is the username
So before you start this, can you list down all the pods in the Argo CD namespace?
Yeah. Namespace. Okay.
The application set controller is failing, it's fine, no worries, because I think the CRD installation failed there due to some annotation length, but that's fine. Just ignore this. But look at the rest of the component. So we have seen the Argo CD architecture, right? So we have seen all these components. First one is application controller. So that's where it checks the trips and against your cluster and Git. So that's the use of it. And then the third pod is the tech server for authentication, as you rightly pointed out. Notification controller for sending notification to the external applications. So that's the use of notification controller. And Redis cache, it's for maintaining the local cache of your Git manifest. Repo server. So repo server is the one that collects the data from the Git and then pushing it to the Redis cache. So that's the use of repo server. And Argo CD server is your the heart of your Argo CD application. That is where you are accessing the Argo CD UI. So basically, you are doing a port forward of the Argo CD server, where all the calls will go through Argo CD server. So we are not making any call to application controller or application or other application pods. Right? So all the calls that are made is going to the server, Argo CD server. So that's where you did a port forward. So we have not done any SSO authentications. Okay. So you will have by default admin ID will be enabled. So how to get the admin ID password? Yes. So by default, whenever you create any Argo CD installation, so Argo CD initial admin secret will be created in the Argo CD namespace. Okay. So that is going to be your password. You can copy this and your username will be admin. So go to settings. So just look at all these, click on clusters first, yeah, clusters. So by default, when you install Argo CD, it's going to add your local cluster where your Argo CD installed, that is my in cluster. So basically Kubernetes.default.service, this is my Kubernetes service for accessing this server. So it's going to add them by default. Okay. So if you had any remote server, then you will see all the cluster listed here. So from UI, you will not be able to add clusters, but from Argo CD CLI, you can create clusters. Okay. But this is where I was talking about multi-cluster. So I want you, if you have time, just to go back after this session and then try adding another remote server. Okay. See how it works. But for this, you might have to have connectivity. Try to explore it. So we are not going to make use of this multi-cluster, but just understand how to create the clusters. Okay. So go back to the setting again. Click on projects. So project means by default, it creates a default project. So for each and every team member, you can create a project. You can create a project, yes. And then just in the source repository, you're seeing star, right? So instead of star, what you have to give? You have to give a dev team's repository, like GitHub repository link. So if they manage a single repository, then you can provide that specific repository. So all the files from that repository will be synced. So this is the repo configuration. So that project has this repository information, like what repository it can sync. So where it can sync, whether it can sync to in cluster or it can sync to dev teams cluster. So that configuration you can give. That's your destination cluster. Come down. Yeah, so you can configure any service accounts. You can create any allow or list. For example, if you don't want that team to have access to your resource quota. So resource quota means every specific namespace can access whatever CPU and memory limit you have defined. For example, dev team is not running an intensive application. Maximum they can consume across their namespace with 20 core CPU and some 32 GB memory. So you can create a resource quota. So if it exceeds this, for example, if they do a lot of deployments, if it exceeds this limit that we are setting, then it will not work. So for that, what they can do, they can adjust the resource quota themselves. But if they adjust it, they can increase it to 100 cores also. So they can consume the entire cluster capacity. So in that case, you should not allow them to restrict all the manifests that are there in that namespace. So you have to restrict few of them. So that's why allow list is there, restrict list is there. So in the deny list, you will have to configure resource quota. Or in the allow list, you can configure only deployment service, all the files that you listed. Those files you can just allow, and then you can deny few applications as well. So few Kubernetes manifest as well. One such case is resource quota. So resource quota addition will have to be done by cluster admin, which is you in this case. Okay, right? So that's on the projects. So basically multi-cluster and projects, these all will come into multi-tenancy, managing multi-tenancy, which means managing more than one cluster or more than one organization. So that's why we will mention it as multi-tenancy. So how that can be achieved using multiple projects and multiple clusters. Okay, so with this combination only we'll achieve multi-tenancy. Okay, so that's on the project. Go back to the setting. Right, accounts. So for now, you are logging in as admin, right? So you can add few more local users and then configure that local user. Using that local user, anybody can access the Argo CD UI. So so this password is hard to remember, right? So you can create a new user and then create a password for them and then share it. So that's your local user. That is the reason for having an account. Yeah. Go back. Yeah, that's the appearance. You don't need to check too much of it. That's fine. So click on the settings again. So click on the repository. So unknown host certificates are basically for authentication. That's fine. So connect a repo. Click on HTTP. So either you can give SSH keys to authenticate or HTTP or HTTPS. Click on that. So basically you are going to connect it and then you can define a project, but you can choose default for now. So we are not going to create multiple projects and then explore. But yeah, repository URL is this one. Basically, you need to configure password, right? But you don't have password to access this repository. I will share it in the chat. So that's my PAD token. I have given for maybe for today only. So it will expire in some time. So you can use that PAD token, but you can create your own PAD token to authenticate to the Git repository, right? But for now, I'm sharing my PAD token, but you have to use your own PAD tokens. If you are repeating this lab, so you have to create your own PAD token and then repeat this. Yeah, you can paste the password which I shared in the chat.
In the password itself?
Yes.
Bearer token. Okay. So,
Should I have to enable?
No, nothing else. Just the username password is enough. So it's my public repository. So it's
Username?
to provide username, not required.
Okay. Connect.
Yes. Successful. It is able to authenticate using the PAD token. So if there are any problems in syncing, first place you have to check whether this connection status is successful or not. My PAT token expires tomorrow. If this is going to be in failure state, okay, then you'll.
Ma'am, but I have one question. As the repository is public, do we need a PAT token?
But still, it's better to configure the PAT token. So it's not for this
Okay.
purpose. So the intention is how you will configure it in the live environment. So you don't need a PAT token. But I think PAT token, the password is a mandatory parameter here.
No, it was optional
It was
actually.
optional. Okay, but it's but for a private repository, this is required. It is
Okay.
Okay, no worries. Okay, my bad. I think for the private repository, this is, yeah, even though it says optional, it is not going to be a successful connectivity, right? It's going to be failed. So you have to project the username password in that case, or you can have an SSH key. Yeah, so multiple ways to configure. Okay, so now you have access to this repository. So yeah, you can continue the lab. Go to the README. Yes, I think I've mentioned the instruction. So you'll have to go to the Argo CD UI settings repository. We have connected the repository. Okay. First step is done. Line number 75. Go to the line number 75. So that's done. And then Helm repository. So this is also fine. Just to go down. Okay. Okay, go to the Argo CD UI. I'll instruct what to do. Go to the application. New app. Give any name. Click on default. Manual. Keep it manual. Manual fine. So we are going to test manual. And then come down. Repository URL is this and path is week 6.
Branch.
That's fine.
Okay.
Path is week 6.
It's not sure.
Week 6 slash. So do one thing. Just to copy the, from here. Week 6. No. Go to the week 6 folder. Argo CD UI manifest. Click on that. So copy this. Copy this entire path. No. So from week 6 to Argo CD UI. Starting from week 6. Yeah. So you are going to sync all the files in the Argo UI manifest folder. So that's the path. In cluster URL, you can configure remote cluster or in cluster also. So click on the cluster URL. It should give you a drop down. Click on this.
I'm just clicking on it.
Okay, come down. Okay, it should show in cluster. But that's fine. You just click on create. Let's see what's happening. It is not able to authenticate your cluster. Can you click on the URL and see if it's listing any pop-up? Cluster URL. Come down in the under the destination field. Did it show anything?
No, nothing.
Oh, that's fine. So that's not the problem. The problem is with the cluster URL. So maybe the cluster is not working for you, I guess. Can you just go back? Go back to the Argo settings field. do one thing, create another, yeah, that's right. Click on clusters. You should see this in
Connection status is unknown. Oh, that is interesting.
okay, just a moment, let me check. I think your cluster is Argo CD is not able to direct your cluster. I don't know why, but let me check if it's working for you. So you can, meantime, what you can do, you can explore the YAMLs. I will start my cluster and then we'll share my machine. Okay. So what we are going to do, we are going to deploy manual sync, automated sync to test the rollback, all that stuff. Yeah. If anyone else is also doing the lab parallelly, if your machine is working, just share. All right. Is my terminal visible?
Yes.
So I'm getting certificate error because I'm not integrated cert manager, and then I'm not configured HTTPS for this application. If you don't want this, you'll have to configure a cert manager and configure a certificate and then authenticate after that. Okay, so basically what you need a host for your application and then configure it in the cert manager and then create the certificate. And once the certificate is there, you'll have to attach it in your ingress. So then only your URL, app URL will work. So for now, we are just using code forward method, but you will have to configure cert manager along with your ingress for routing. So these both are required. Certificate for certificate management, ingress for routing your URL to your application. Okay, the application pod. So you'll have to configure both of them. Okay. I think I have created a UI app already. Let me check. Let's see, configure UI app. I'm going to create a default manual. The repository URL is this one. Path is going to be v6 / argo. So I've created the app already, so I'm just deleting it. This is fine. So, yeah. This is my UI app. So why it is out of sync? Any guess? Any guess? Sorry. Abhishek, can you tell me why it is out of sync?
Because we have deleted the existing app from the same thing or something.
Okay. No, we have not deleted. So I see still.
Not set up the interval yet.
We haven't configured auto sync in configuration.
Exactly. Who is that? Abhishek, right?
Yeah.
No.
Okay, that's right. So here we have not configured auto sync. So first time sync, I have not configured auto sync. I've kept it manual. So then it is waiting, right? Then it's waiting for the application to sync. So it just says told that out of sync. So now I enabled the auto sync. So in the next cycle, it will pick up and then it will start syncing. I see some errors. Let's see. And then one good advantage that I see with Argo CD is you don't need to do a describe command to check the configuration errors or logs also it can show. So both the things you can identify. So these are all events. So you will get it with kubectl describe command. So you don't need to run the describe at all from now onwards. It's going to say what's missing, right? Did it really sync? So this is the drift. So you are seeing all the errors. I think I did space, I guess. Let me check. Okay, resync it. Let's see. There it is. After deployment, nothing's fancy. So to check what is the latest commit that it is syncing, just click on this. It will take you to the latest commit that it is being syncing. Okay. And for the sync error, you can just check here, and then for the conditional errors, you can check here. So all these are events for this application. So let me check if I have any other duplicate application for the same. So let me do one thing. I think it is requiring a namespace. Let me configure the namespace because it is mentioning that.
I don't see namespace YAML in repository.
Okay. So let me add the namespace. I don't have the namespace YAML, that's right. And then if I see it here, now it should complain me namespace missing because I have not created the namespace, I guess. So let me sync in. Since it is an auto sync, I have to give sync every time. Test UI cluster option retry. So it's going to retry better spelling. I don't have to resync every time. Then auto create namespace. Let's see now. So basically, I have to give all the details which are required for my deployment. So that's why it was waiting for the namespace. So even after giving the namespace also, it failed. Why? I did not enable the namespace creation. So here there is an option to auto create namespace if it is missing. Okay. So that can automatically create the app namespace and then propagate all the application. You don't need to specifically have the namespace YAML configured. So I purposefully removed the namespace creation at all so that Argo CD can create the namespace from here. Okay. So now we can.
Lavanya, I have a doubt.
Yes.
We have mentioned test UI as namespace in this Argo CD UI. But in a repo, we haven't mentioned namespace in any of the YAML files. So they could go into default, right?
So you have not mentioned it. So basically, you are right. If you do not mention anything, it goes in the default namespace. But when you are taking it from Argo CD, you should specify default namespace here. Otherwise, it is not going to know where it has to be deployed.
Okay.
So here you can give default, and then you have to sync. So that's it. So this is a mandatory parameter, I would say.
Okay.
Okay.
So if we mention here, we can ignore in YAML files, resource files. So.
Exactly. Yes. So I will check the namespace. Test UI. Yeah. So it's going to create my namespace and then it is going to deploy all the YAMLs that I mentioned there. If Cuddle get all is going to list all the deployment in the namespace. So it's going to list me all the pods, services, deployments. Yeah. So whatever required, it's going to list me there. So basically I have to check test UI, right? Test.
Typo UI.
Yeah, right. The HPA replicas, all the files that I mentioned in the repository, so it's all there. So which is good. So let me have disabled the auto sync, right? Now I'm going to change the version. Maybe change it to 23. I don't know if 26 is there, but yeah. It seems. Let me check my Argo CD repo URL. So usually you will not see this lag since we are testing it in test environment. You have to check the logs of the repo server. So in such case, you'll have to check all these things. If there are any problems, yeah. So it just needs a refresh. So basically it refreshes in some time. So we should have waited 3 minutes to check the out of sync status. But yeah, so either you can wait for 3 minutes or just click on this refresh button then you are seeing out of sync. Why you are seeing out of sync? Because we did not enable auto sync. So I'm just enabling it. Then it did. Ideally, it should have waited 3 minutes, but since we enabled auto sync, it checks the status. Already out of sync is there, so it is progressing with the sync. So now if I check my deployment, should be with 23. So yeah, it's doing the rollout. So if you see two versions, you are seeing, right? One is the latest one, other one is the previous replica set. So this is how the Jupyter rollback will work, but you can do one thing. Go to the details, parameters. So this is your manifest structure. So which project you're deploying, what is the source, what is the destination, and what is the namespace, and sync policy we were talking about. So automated sync enabled, create namespace is enabled. So retry for 2 minutes. If it fails for some reason, it will be in failed state. So how to list the application that are in failed state? So just to click on this healthy status, all the healthy applications will be listed here. So if you want to check degraded application, so for some reason it's degraded, so you will see the degraded apps. So you can filter and then troubleshoot based on that. Okay. So that is with the UI. So one way of doing it is from the UI, but we need another way of deploying this, right? So you don't need to create a Argo CD app every time from the UI. All that you have to do is you have to just create the Argo CD application and then sync the apps. So basically the same thing. So in UI I've created, you have seen this manifest files, right? So this manifest file. The same thing I'll put it in Argo CD application YAML. So this is my Argo CD. This is the Argo CD CRD for application. So I'm calling the application object, and then my name of the application is Argo CD UI app. And yeah, I think I don't want that in the Argo CD namespace, but still fine. No worries. We'll see. So the same thing that we have created, week 6 UI main. So all the configuration that we saw here can be moved here, like the project configuration. And just to create this Argo CD application, it's going to create the Argo application in the UI. Okay. So that's the direct manifest that are there in this path. But if you have Helm repositories, that also you can sync in. For example, this is another Argo CD application. This is a Helm based application that I'm creating in the namespace Argo CD, and then project is default. I'm syncing a Bitnami chart for Ingress Nginx controller with specific version 12.0.7. So basically, it is going to sync the Helm chart in your cluster. So basically, it's going to create multiple folders, multiple manifests that are mentioned in the Helm repository template folder. You remember template folder will have all the files. I think we covered it somewhere here, I guess. We covered a Helm repository template. So all these manifests will be created. So we are not mentioning any template folders. All that we are mentioning is the Bitnami chart, and then where we are going to sync in our Ingress Argo. So let me create this YAML and then see what's happening. So you know what it is going to do already. So just yes. So by the time now, it would have created another Argo app in the Argo CD, which is Helm repo. So this one. So this how immediately it created an Helm chart, and then we deployed all the required manifests, and then the pods were also up. So if there are any problems, you can see that in the events. So it just started the application health, and then it has been in degraded state for some time until all the Argo CD application is seamless. So then it became healthy. So if there are any problems, then you will see the errors. So that's why I've created few failure applications. So for example, I'll go back here and then Kyverno application. So yeah, if you see here, it's giving the error. So it's not going to, it's not able to remove something. So it's giving the errors here. So you can also check errors, and then you can also check the events. Okay. So we will see that when we deploy. So from now onwards, you don't need to run the kubectl at all. All that you'll have to do is you will have to just to create the application from Argo CD. Okay. So I was telling about multiple applications, right? Like the cert managers and all. So let's see, we can all, so 10 or 20 health charts we can sync in just 1 or 2 minutes. So this is my Argo Helm app. This is my cert manager application. I have one more application for cert manager. So I'm not going to create a full Helm chart and then configure cert manager. So all that I'm going to do is I'm just going to call that repository and then install the cert manager. And then so cert manager requires cluster issuer. Cluster issuer is nothing but, so they are going to give your certificate. Like Let's Encrypt is a mechanism to issue certificate for you. So basically it's required only for non-prod. So not production. For production, we don't use Let's Encrypt. So basically you get the certificate from some authorized from some external CA, and then get the certificate and then pass it on to an Nginx ingress controller. So I'm just using the cluster issuer, and then I am creating another application for Nginx. And then, yeah, this is the sample app. So yeah, these are all just Nginx. So this is my one. So I've just picked up few random YAMLs just to deploy the application. Okay. So let me check by deploying all of them. So indeed, so just imagine without Argo CD, Ganesh, as you said, you're not using Argo CD for your application. So you'll have to manage. So for the application team, onboarding is done using CI/CD pipeline. But still you'll have to configure your cert managers, Kyverno, Kiali, Istio, Nginx Ingress. All these are your tools. You are managing it. How you will manage it? Still you'll have to manage some tools, right? Either you do kubectl apply or Helm upgrade or Helm install. So you'll have to run these commands manually. Or create a CI/CD pipeline specifically for your applications and manage them. So how many CI/CD pipeline? Yeah, n number of apps means n number of CI/CD pipeline. Upgrades or not just now we did an upgrade of version 24 to 23. So how quick that was. But if you have to do an upgrade, to do the changes and then do the checks and then do the CI/CD pipeline trigger, wait for it to sync it up carefully, like just check without any problems in the CI/CD pipeline. So it would take a lot of time. So you are not creating a single pipeline for all of this application, right? You'll have to have a separate pipeline for each of these. So what's the advantage of using Argo CD? Just in one go, I have one infra repository. So from infra repository, I'm managing all the tools. Okay, even Istio. So in the last sessions, we have deployed few applications, right? So it's all Helm-based applications. So I've installed Istio-D, Istio Ingress, Egress, Istio base. So all these are deployed. Okay. So these are all, if you see, it's a Helm chart. If you see a Git, then it is a pulling from the Git repository. Okay. Any doubt with the Argo CD?
No, maybe for me, I love to rewatch once again. I followed through, but I want to do it practically. Then I think I'll.
Yes, please do the lab. I want everyone to experience the lab. So, yeah, then only you will follow it completely.
So if I follow the README and the proper prerequisites, then I should be able to do it, right?
That's right. That's right.
Week 6. Okay.
Yes, week 6. So every week has a lab. Even from starting from kind cluster, I have given the instruction. Okay. Okay. Yeah. So just follow it. And then I would like to take a break here. Then we'll start with another session, Kyverno. Policy engine for Kyverno. Okay. That's also one important tool So we are mostly covered all the production related tools already. So we have few tools left, Kyverno and monitoring. So will have a dedicated session for monitoring. Next session will be monitoring. So after next session, it's all done with respect to Kubernetes. We will jump into Terraform. Okay. So just don't miss any class. If you miss also, just definitely follow the recording and do the lab assignments. Then only you will get full-fledged experience with the tools. And also, I also recommend everyone to go back and check all the tools. Spend a few time for each and every tool. Read the components. We have not covered 100% of all the tools. So basically, you'll have to dig yourself and do more and more lab assignment because you have the cluster already with you. So there is nothing stopping you to try all the features that are available. So try to use that, and then you have a lot of advantage of using ChatGPT. So if you have any queries, yeah. So, and you can WhatsApp in the group as well for any questions so that we can be prepared, and then we can allocate some time if you have to clear it in the call. Okay. So make use of the session wisely, and then it should definitely help you. Yeah. So now the time is 11:17. So I need 20 minutes break. Let's connect after some time. Okay. Bye. Thank you. Hello. Can we start? Okay, good. So just a quick note on the Argo CD. I have not gone through this SSO configuration. For this, you need a client ID and client secret configured from your Google identity provider. So just for the lab, you can follow the README to create the SSO authentication. Basically, you'll have to come to the Google Cloud providers and then create a client ID and the client secret. So basically, is it for the web application? You have to choose the web application and the application name one. So from where you are accessing your application. So basically, I'm doing from localhost 8080. So if it is your Argo URL, you'll have to configure the Argo CD URL here, and then a callback. So we are going to do a callback with Dex tool from our Argo CD. If it's going to be a OADC, then you'll have to configure the respective callback for that tool. So this is the redirect URI, and then once you have this, you will get the client ID and then client secret. So you will have to use this configuration with the client ID. Basically, you need a client ID and client secret from your identity provider. So this will be same for Azure AD as well, or for any other identity provider as well. All you need is the client ID and the client secret, and what is your identity provider. So all these things you'll have to create from the Google identity provider, and then once you do the port forward, immediately it will ask you for the login. Right, in the login, what did it ask? It asked for user ID and the password. So basically, if you log out, so here you will see a sign-in page. So when you enable the OADC, you will see another login page. So basically, it is going to authenticate using your issuer. Like here in this case, my OADC issuer is Google. So I will get another button to log in with this option. So basically, I have to give my Gmail ID, and then using that, it is going to authenticate. So we have just added the Google identity provider. So it's going to allow me logging in using the SSO for that identity provider. So you have to configure this in the config map, and then just do a rollout restart of these two, because this is where the configurations are stored. So yeah. Still, again, it will give you one error message because we are not enabling certificates. Like we are still having the certificate issue. We are not configuring HTTPS. So for that, to make it work, what you have to do, you have to deploy the tool called Cert Manager. So then you'll have to configure cluster issuer for your host. So using that certificate only, you can use the application without having the certificate errors. So basically, you will have to configure the certificate in the ingress. So these steps you have to do if you are using Cert Manager for securing your authentications. Okay. So if you are not using the secure way of hosting the application, then you'll have to make specifically to access the application in an insecure way. So that's what this patch is doing. And then so now with this, after you port forward, you will be able to access the application with the Google provider. But once you log in, what additional step you need to do? So you'll have to configure roles for that user, right? So how you will configure the roles? So for my ID, for my group, what would be the role? If I am an admin, I have full access. So similarly, you will have other roles as well. So you can assign it. So with this role only, you can configure RBAC for different teams. So basically, you'll have to play with this policy. Yep. So that's it on the continuation of the Argo CD. So just explore the Argo CD further for the progressive rollouts like blue, green, and rollbacks. So all these things you can explore yourself. Yeah. Any query in the Argo CD? Okay, then I think we can proceed.
Ma'am, I have one question.
Yes, please.
Ma'am, in initial stage of the lecture, you informed like on CI/CD we have some issues. So that's why we are going to CD, Argo CD or Flex CD. Actually, what is the issue basically, ma'am?
Which issue?
Like instead of Argo CD or Flex CD, why we cannot be able to use a CI/CD like Jenkins or GitHub Actions?
So, you can use Jenkins or GitHub Action, but how quick is your deployment? So how less your application deployment is error prone. So those are the configuration that you'll have to, those are the decision that you'll have to take care. So if you are going to use other tools. So this Argo CD is sitting on the same cluster where your Kubernetes is deployed, right? So it's going to be very rapid. So you one is the fast delivery, and still you will have multiple advantages of having multi-clusters, RBACs, providing access to application teams so they can see what has been failing. So what are the errors, and then they can visualize it themselves. Yeah.
Okay, ma'am. And what about we have?
So for example, I have 10 application teams, right?
Okay.
So all that I will have is 10 application in my Argo CD that you have just seen, right? So,
yeah.
But consider in case of CI/CD, 10 different CI/CD pipelines. So not even one for a single application. If there are multiple microservices managed by different teams, so they will not be, so imagine the number of pipelines that you create for them, right? It's going to be humongous, right?
Yeah, correct.
So that who will manage it? So that need to be a CI/CD team to sit and watch for errors, right? So that's going to be hard. So we can eliminate all of this with these tools like Gitops tools. The Gitops is a concept. Okay.
Ma'am, and what about we have multiple clusters?
If you have multiple clusters in the Argo CD, we can add multiple clusters as well, right? I just told you how to add multiple clusters. Where is my password? Yes, you can add multiple remote clusters and then access other clusters, like deploy application to the other clusters as well.
Okay, ma'am. But Argo CD can be installed on only one cluster, not on everything.
Not necessarily to be installed on all the clusters, but all the clusters will be on the same network, right?
Yeah.
So it has to talk to. So it will be on the same network. So that's why I told that these are all lying in the same network. So not necessarily of the same cluster, but it is faster compared to others.
Okay.
So dedicated cluster within the same network, right? So we spin up the Argo CD.
Exactly, right, Abhishek. Yes. So if you see here, for now, I have just added in cluster, right? So here you can add multiple clusters as well. So this URL will be, if your application, if your cluster is from AKS URL will be there. So if the cluster is from EKS API URL will be there. So basically, SVC, it's the host cluster where Argo CD is installed. So if it is a remote cluster will have that API server, right? So that API server will be your server in that case. And then you can name it as you want. So yeah, Dev cluster or AKS cluster, EKS cluster, whatever. So how to ensure that application is deployed onto that cluster? So here, if you see, Where is my destination here? Namespace. It's destination here. Yeah, cluster here. So in the cluster, it will list all the added remote clusters as well. So if you just change it, it will be deployed onto that respective cluster. So if you want the same application to be deployed on 3 different clusters, then still you can just create 3 different applications for AKS, EKS, GCP. So 3 clusters, same application will be deployed. All that you will find is 3 different applications. Okay, but you can manage
Okay.
it. But
Okay,
in
ma'am.
CI pipeline, this is going to be a tough job managing for each microservices or per environment. Yeah, and the cost.
Okay, ma'am.
Imagine the cost of that is the cost for every runs, right? So, but
Yeah.
the cost is completely eliminated. Not to the zero cost, but still you have to have the compute cost for Argo CD deployment. But other than that, what cost it is doing? Nothing. So there is no cost for the repo server to host, right? So there is no cost for every run. It's running for every 3 minutes. We are not charging there. So the cost is
Got it.
completely eliminated there. No need of agents, no need of VMs to run it, right? So, but in case of CI, CD, Jenkins, you need machines to run behind the scenes.
Yeah.
So
Correct.
it be physical or virtual or an agent that spins up when the job runs. So it is computational will be too much, right, compared to this. So it's just a
Yeah.
pod deployed into a Kubernetes cluster. So a lot of advantage you can imagine, and then you can jot down the pros and cons of it.
Okay, ma'am. And ma'am, what about the network? I'm sorry if I'm asking very basic question.
Okay.
How can we make it everything align in the same network? How can we ensure?
Basically, network in the sense, so with respect to this single Argo CD instance, so where it is currently deployed?
In our kind cluster.
In our kind cluster. That's my host
Yeah.
cluster, right?
Yeah.
So how it is created host cluster? Using the pod CIDR that I configured. But in production, how this cluster will be configured? So imagine the cluster is a bare metal cluster. So your organization will allocate some CIDR for creating the cluster, right? For
Yes. Yeah.
creating a cluster. So that
Yeah.
IP, so within that IP range only your Argo CD will come into picture. So
Got it, ma'am. So this is under a VPC configurations kind of. Everything should under the same subnet.
same VNet, virtual network, VPC. Yes.
Got it. Yeah. Thank you.
Yeah. So basically, if it is, for example, if your agent, Azure DevOps agent is in different network, then your Argo, your cluster will need to have a communication channel between them. So in that case, you'll have to configure agent, private agent, not the public agent, to deploy it into your private cluster, right? So those things you need to take care. But I'm not saying that full advantage of using the Argo CD, but just imagine what is the need of your application. So based on that, you have to decide whether you need Argo CD itself or you can manage the CI/CD pipeline. That's it.
You got it. Thank you.
But if you're leveraging Kubernetes, I would say leverage with the entire ecosystem and make full use of it. So, yeah.
Okay.
So in the CI, if we want to include the SonarQube and the basic unit testing kind of steps, so we'll be creating a separate CI in Jenkins, and for CD we'll go with the Argo CD. Is that the flow? How the flow?
Yes, right. So we are not touching the CI at all. CI is still going to be the same. So we are not eliminating the need of CI. So this is the flow that you were talking about, right?
Yes.
So you can add testings and integrate SonarQube and do the code quality check here. Yeah, and then based on the result, SonarQube report, you can deny it or whatever you want. You can do it based on the configuration that you have given in the CI. So Argo CD is coming in CD picture. It's not coming in CI picture. It's for
How
CI.
the trigger happens from CI to CD? once all the process is done till the GitHub container registry, then how it will trigger back to the CD.
So basically how Argo CD works based on the application, right? Based on the application means this one. Okay.
Yeah.
So what does this application means? Argo CD is just an application. Application is nothing but watch the repo. Which repo? AH Terraform MC. So your CI pipeline should push something to this repository, right?
Yes.
So then only CD gets picked up. So these two are separate lines. Okay, so we are not dependent on CI anymore. So we are just dependent on this repository. So pushing it to this repository, it can be from the CI or using some other mechanism as well. So usually they will build the image and just update the image references from their pipeline and then commit it to this repository.
Okay.
Yeah, so this is CI/CD is not affected. So all that we are watching is this repo URL.
So basically, Docker image reference gets changed. That's how this gets triggered CD.
So it's not for the Docker image change. Any change that's there in the deployment YAML, any change that's there in the manifest that are configured to watch this path, in this repository. So any change, if you do it, it will immediately be picked up. Okay.
Okay.
Basically, if I give, yeah.
So usually we prefer that image reference, right? I mean, like.
Yes, yeah. So that's how the release works, right?
Yeah.
So new release means new version, and sometimes they will add a new configuration as well. So if they add probes, those changes will also come into picture. So previously we don't have any probes, means if you add some probes, then that will also be in a release. So but basically image change is a release, that's for sure.
Okay.
Okay, adding a new microservice is a release, right? In the same repository, you can add few more files and then a new application will be deployed. That's also one thing. So you can add 10 deployments, 10 services, yeah, 10 HPAs, 10 role bindings, 10 what else? Ingress, everything you can configure under this one folder. So 10 applications will be managed, 10 microservices will be managed. For the entire Argo, application, if you watch your organization repo, so you have one repository for onboarding. Say your application team name is Kubernetes, and then the Kubernetes team, and then you manage a repository called Kubernetes onboarding. So whatever the manifest files that are pushed to the Kubernetes onboarding repository, immediately changes will be picked up. So basically how it will be done. So just to rephrase, yeah. So this is my K8 onboarding repo, specifically designed for onboarding applications to your cluster. So I will have 10 folders: dev, test, staging. Yeah, so maybe an additional West Europe, US dev, US test, US staging. So or either like this with respect to specific environment, or you can do with the team names like finance, as we discussed, HR, application. This is not a flow, but yeah. What else? Yeah. Infra, your own Teams app. So these are all different applications, right? So a single repository. So these are all folders inside that repository, like week 1, week 2 we have, right? So instead of watching the Argo CD UI folder, what I will do, I will watch the entire K8 onboarding folder itself. So this folder this repository I'll watch, And in the main folder, like if you don't mention any path, so whatever is there in that revision or main branch, it will sync. So I have folders for finance, HR, infra, payment. So all these will be managed by Argo CD automatically. Okay. So single repository you can manage, or create multiple repositories for each and everything, that also you can do. So based on the strategy that is being designed. Yeah. Did that answer, Pulaka? Good, right?
Yes, Lavanya.
Okay. So let's move on to the next tool that we plan to look today, which is Kyverno. So anybody heard of this tool, Kyverno?
Yes, Lavanya.
Policy engine.
Right. Why do we need a policy?
So it acts as an admission controller, so it intercepts with the API requests, and it can set some policies like privileged root controllers controlling, and also something like resource limits, making resource and limits mandatory, and also enforcing some of the policies like we just need signed images in our environment, something like those.
So you pretty much covered what we are going to see today. So yeah, basically Kyverno is a Kubernetes native, cloud native policy engine. So just to validate your configurations are as per the standards defined by your organization. So that is what it is going to check. What are the standards? We will see that. Okay. So yeah. Now we have the full Kubernetes cluster open to your application teams. So they can deploy their deployment YAML however they want, right? So they can pull a public image, they can configure the application without probes, without liveness probe, without readiness probe, without labeling, and then by configuring as root user for your application. So by so with root user, you get all the permissions. Like you can connect to your host and then do whatever you want. So that type of flexibility they will get. But are we restricting anything? So only thing that we can restrict is with network policy, the communication can be stopped between the namespaces. And with HTO, you can stop the external world communication. But what to stop within the deployment YAML, what to allow, what to deny. So that type of mechanism is not there by default, right? So it is open. It's too much. Like they can do whatever they want. So they can deploy any resource. For example, they can deploy a load balancer, right? We have seen deploying a load balancer and access the application using the IP, which means it's not secure. So if the application is not secured, there is no SSO, then the application can be accessible publicly without even using password and username as well. So which means your application is accessible publicly with load balancer. So do you think that's safe? No, right? So we should not expose the application publicly without having any security mechanism. So those things should be restricted. So after having after going through these many sessions, do you think we need a load balancer at all? Can you answer? Do you think we need load balancer service at all? Okay.
We need load balancer. That's how we will get access to the cluster.
Okay. So basically, the Kubernetes native load balancer is not required anymore. So all that you need is ingress controller, Nginx ingress controller or HTO ingress controller. So whatever ingress controllers you need, that specific IP you can create and allow. But that can be done by cluster admin, right? Not by all of them. So only cluster admin can create load balancer. None of the other team members can create. Not the development team. They cannot create any load balancer, right? So anyways, we are not going to create a load balancer service type at all. So basically, we will embed it with the ingress controller. So that's what we are going to do. So we are going to restrict the load balancer creation. We are going to restrict the node code creation. Do we need node code? Not really in the production. So we'll have to restrict them. So in the deployment YAML, what are the recommended best practices in the deployment YAML? So you need definitely labels and not just the Nginx label. So in the production, you need app ID. Okay. App ID means each and every application ID will have a unique number to identify, like 1, 2, 3, 4 or something. Or what other options? Cost center. Okay, cost center. So based on that, this application will be built. So not all application are critical. Not all application are using high resources. So you will have to project your cost, right? So to project the cost, we need something. So how you will decide which application is falling into which cost center. So we need such labels, right, to identify them. So basically, a namespace should be tied to this cost center. Means it falls under DevOps team. It falls under finance team. So that type of tagging you can do it. So while visualizing the cost, it will give you that segregation per namespace or per deployment. So based on the label, you can filter the data and analyze it. So these are the best practices. All the best practices can be enforced using Kyverno policy engine. So basically, it does multiple things. So before creating a deployment, so if I give kubectl create deployment, so create -f and deployment. So if you have the policy deployed to check whether cost center is added, whether the image is from private repository or so it should not have the latest version. So that's one thing. And then it should have the port. And then it should have the, what is that? What's the best practice? Probes, right? So it should have readiness probe. It should have liveliness probe. So all these things. And then it should not have security context with root privilege. So enforced escalation should be false. So all these are best practices when you create a deployment. So far we were been using just Nginx deployment. Now we are digging deep into all the best practices configuration in the YAML. So how to enforce it? So for now we don't have any enforcing mechanism, right? So how this will be achieved? It is achieved using policy engine. So one such tool is Kyverno. There are other tools like OPA, Gatekeeper. So Gatekeeper is another competitor for Kyverno, which was there for quite some time. So before Kyverno, this Gatekeeper was there. So that was also quite famous as compared to Kyverno. Kyverno is becoming famous in recent days because you can create a policy with just YAML files. But when it comes to Gatekeeper, so you'll have to know a different language called Rego expressions. So using Rego only, it is going to create the policy. But when it comes to Kubernetes, we have everything is coming from YAMLs, right? So similarly, your Kyverno policy is also coming from YAML-based deployment. Okay. So what does it do? It validates a resource. It checks whether based on the validation and parameter that we have defined, it will check whether we have the cost center, whether we have pulling it from specific image repositories, and then whether we have configured the probes. All these are validations. But there is something called as mutate. Mutate means change. For example, if you don't have cost center, add the cost center. So then it will add the cost center. For example, if I have the deploy namespace that's added to a cost center, but your deployment is not creating a cost center, you can just propagate this field from the namespace, right? So this cost center will be added to all your deployment, which means it is going to change the resource, mutate the resource. Okay. Yeah. So that's the mutate option. And then another option is generate. So if I have the deployment YAML, okay, it checks this deployment YAML, and then you can generate few other resources as well. So if you don't want them to be configuring the ingress, you can generate the resource. You can generate the configuration for them. Okay. So such type of resources are coming into generate configuration. Okay. So let's move on to the PowerPoint and see what we have. So Kubernetes is flexible but not strict. So we don't have any enforcing mechanism by default. So that's the problem. So they can deploy anything without following the best practices. That's another problem, and it has security risk. So no built-in enforcement by default. So these are the problem statement. So how it can be enforced? It can be enforced using policies. So these policies are provided by various tools. Like OPA Gatekeeper, another one is Kyverno Policy Engine. So behind the scenes, the concept is same. Okay. Yeah. So Kyverno is built specifically for Kubernetes, and then if you deploy, so Kyverno will be deployed using the Helm chart, using the Kyverno repository, and then it deploys few CRDs. So basically, it's all CRDs when you deploy any external tools, right? So we will make use of policies like cluster policy and the policy. We'll see what's the difference between these two. And then, yeah, so it uses YAML to generate. So basically it works at admission of any resource. Admission controller, nothing but during the creation of any resource. So this policy will be invoked during any resource creation. So any resource creation, in the sense, if you create any deployment, if you have a policy targeting that deployment, then immediately that policy will be invoked, and whatever you say it in the policy, it will validate. If it validates, if it is well and good, it follows whatever you are recommending, then it is going to allow the resource creation. If not, it is going to block. It is falling under violation. It is going to block the resource. Okay, so no team will be able to create a deployment without cost center label, without probes, without without a private repository or allowed repository. So all these best practices, you can enforce it with Kyverno. Okay. Yeah. So you can integrate, you can integrate Argo CD. Argo CD will send the request. So basically, where these interception will happen. So it is going to intercept your Kube API for request at all. So whenever you create a deployment, first thing what it is going to do, it is going to your Kubernetes API server, and then once the deployment is created, it will create, it will ask the schedulers to schedule the pods onto the available nodes. So this is the flow, right, with respect to Kubernetes. So where this interception, the Kyverno interception will happen before reaching the Kubernetes API server. So your call will be intercepted and validated. If it is validated, if it's allowed, then it will allow. If there is a violation, then it will be blocked. So this is where it is coming into picture. Before even going to Kube API server, first call will go to your Kyverno. Okay, Kyverno controller. So if you create an application using kubectl or Argo CD, whatever way, that's fine. It goes to your Kubernetes API. So immediately your Kyverno will come into picture, and then it will check whether to allow or deny. Then based on this decision only, this resource will be created or denied. Okay. So basically, if it detects any violation, it blocks that specific deployment. So common type of rules is validate. Any blocks any invalid configuration. Mutates means modifies the resources automatically. A use case will be adding a label, or you can configure the probes as well for default port. Okay, and then generate the resources automatically. For example, I think someone asked for the egress policy, right? So you denied all the egress by default with Istio. So then what they have to create, they'll have to have a service entry, right? Service entry can be a generate resource. So in the service entry, you can mention few default URLs that's allowed, right? So those URLs will be automatically allowed for them. So service entry. Service entry is one such resource that comes into generative. So imagine, like you can just expand the use case however you want. Like what is your requirement? It can be achieved using what is your best practices in your organization. What is your best practice for specific application? All those things can be achieved using the policy engine called Kyverno. Okay. Yeah. So capabilities, validate, mutate, generate. So just reiterating. Another also, it can check the image security. So you can configure few set of image repositories to allow or block the image pools. So it will check only the specific repository is configured in your deployment. For example, so now I am using the public repository. So Docker registry, it will check, and then if the image is there, it will be pulled. But if I configure specific image repositories like GHCR or ACR or ECR, so all these repositories are only allowed. So in that case, if you allow them, then my public Docker registry will be denied, right? So you have to configure those image repository to verify the image integration, image work. Yeah. So you verify the image security. Okay. So only from the allowed repository. So do you think that we will only allow ACR and ECR? No. So we have to allow few other additional repository. For example, my cluster will download from QA repository. Some of the images will be deployed from QA repository. So that QA image has to be allowed. So you have to evaluate and then verify which repository is allowed in your cluster. So that you have to verify it and then you can add it. So these are the things that you can do with Kyverno. Yeah. Can always deploy any unsafe deployment. And there is something called as PSA, Pod Security Admission Standard. So you can, I think you can go ahead and then check what is PSA. So this is one important standard that is being followed. So maybe we can open and see what are the PSA. So basically, these are the policies, the pod security standards that are enforced by Kubernetes itself. So if you don't know where to start, if you don't know how to enforce the best recommendation, just check here. And what does it say? So whether you need a host process access, whether you need to access host namespaces, privileged containers. So all these are pod security standards. So you can check what need to be allowed and what need to be denied. So based on this, you can check. So there are different levels of pod security standards. So when you have time, you have to go through this. When it comes to security, you'll have to know what is privileged, baseline, restricted. Privilege means so known privilege escalations will be denied here. Baseline means so it is better than privilege. So it has more standards compared to privilege. So this is your starting point, and then next level restricted means all the violations will be restricted with this policy. So this is where the privileged one will have very least security standards. Restricted means more security standards. Like if you compare privileged to restricted, you will have lot of policies. Okay, to restrict. So all these things can be achieved using Kyverno as well. So either you can use pod security admission to restrict all these things, or you can enforce it using the Kyverno policy. Okay. Yeah. So these are some of the PSA standards that you will have to know. So based on that, your cluster need to be configured to have the safe and secure application. Okay. Additionally, you can configure what YAML is required, what need to be rejected, what configuration is allowed for the specific application. So generate manifest is nothing but add missing labels or enforce the naming standards. So if you have to name in certain way, then that naming will also be validated using a regex pattern in the Kyverno policy. Okay. So you can combine Kyverno with Argo CD. Yeah, Argo CD is a deployment engine but Kyverno is your policy engine. While getting all the deployment that comes into your cluster. So it can be either using kubectl or Argo CD, whatever. Yeah. So, but we can use it in combination of this. So Kyverno also has a UI to see what policies are failing or what policies are succeeding, but you'll have to enable that UI and then make use of it. So what's the real use case? So basically you can configure the readiness, liveness and label checks, and then you can configure the resource quota, resource limitation, image validation, all these things you can validate, and then do not use label the latest image tag. So that is a must, because if you use latest, always it is going to hold the latest image. So whenever there is an update in the application repository, they will always add it in the latest version. So you should not pull the latest image to avoid any disruption. So you should always have a tagging mechanism or SHA to validate your application images. So you should not use latest. So you can restrict it with a Kyverno policy. And then, as we already discussed, you can restrict the image repository and you can configure the pod security as we have seen. And then we can allow resource creation or deny few resource creation for by the application team itself. Okay. Yeah. And mode is, so do you think that we will deny it by on the day that we deploy Kyverno? No. So if you deny it on the day one, it is going to deny all of them, right? So always what we will do, we will start with audit mode for the violations, and then we will observe it in the UI, what policies are violated. If it is violated, you will have to reach out to the teams to fix the violations. So then watch for a month and then change it to enforce mode. So as soon as you change it to enforce mode, your new resource provisioning with violation will not work. So for the existing resource also, you can validate using the background controller. So that's possible. That we can do. But before doing the enforcement, you'll have to be carefully analyzed. So that's the point. Okay. Yeah, any questions? So basically these policies that I was talking about, policies, these policies can be kept in the Git repository as well. And then you can create an Argo CD application to create the policy itself. So policy itself will be managed as a code, and then it can be pushed to the Git, and then your Argo CD can sync the policy to your cluster. So if you change any policy, if you add any new policy, it will be automatically synced. So it is going to improve the security posture of your application. For example, in the production, time to time, there will be security audits running on your cluster, right? So basically what they will do, they will validate all the security violations. So those validation or violation, you can capture it, and then all these can be addressed. So most of them can be addressed using Kyverno. And so if you deploy a Kyverno policy, it is going to block the next resource creation. So with that, you can increase the security and governance composure of your application. And it works with Gitops. It's going to sync way faster than like other resources. Yeah. Yeah.
Yeah,
Question?
Lavanya. So if we have 3 clusters, we have to enforce the CRDs accordingly, right? For each cluster.
Yes, it is going to be on that cluster. So it is not good. So like Argo CD, this is not going to watch on a different cluster. So basically, you will have to deploy this Kyverno policy on the cluster, and then you will have to deploy the validation policy or mutating policy. Then that cluster will be watched by your Kyverno. Any API request, it will be watched and then checked for violation. If violation, then log the resource. If not, it will be allowed.
Okay. So this has to be designed from the start of the architecture design, like, or it can, like we said, there is an for existing state also we can apply. You said, right?
Yes, or you can So nobody will do it at the start, right? During the
Yeah.
architectural phase, what people will do, they will start with minimal applications,
Deployments. Yeah.
right? Not with all the best practices, right? The people will say, yeah,
Feedback.
do
Yeah.
it on the day one, but that's not possible. So you'll have to keep adding the tools as and when required, right? So, for example, when this will come into picture, if there is a audit that's happening, so we need
Yeah.
some mechanism to enforce all of them, right? So in
Yes.
that case, what we will do, so we'll analyze it, and then we need a policy engine. Then we decide whether we go with Gatekeeper or Kyverno. So and then go for that tool, and then with that tool, you'll have to configure the violations. So it's not going to be your day one operation. So on the existing cluster, so this enforcement mode will be helpful for the existing cluster. So
To
audit for,
standardize. Yeah.
audit for some time and then enforce it. So if it is brand new cluster, very easy. After day one, I will enforce it, right? Day one, I will create all the PSA standards and then just restrict it on the day one. So that's for the new architecture, but this is not going to be a day-to-day operation, right? So basically, you can enforce your existing clusters as well after auditing for a month or so and see what violation we are doing. The process of moving the audit to enforce is going to be a painful job. People will not change it. So you
Yeah,
have to enforce multiple times. So this is going to be a gap. Yeah, so that is
Yeah.
needed.
Basically, it gets tested in non-prod environment first or something like that, right?
Yes, non-prod audit mode, and
Yeah.
then watch it for some time. When you think that it is good to enforce, then enforce it.
Yeah.
But new resources will not be allowed with violation. But existing resources also, if the application is running, then fine. If it gets restarted, then after enforcement, it will fail if there is a violation. So all the existing resources need to be fixed before moving into enforce. Okay.
Okay. Okay. Yeah. So the security rules like the root user, pod security context, all these I have faced. We have done manual changes and we didn't have the Kyverno policy to standardize. So because of the security scan results, we implemented all those things. So here the security team comes in and implement the Kyverno policies and the DevOps team deploys the policies.
No,
Or whom?
they won't come in and deploy anything for you. So they will come and show the report what
Okay.
your cluster is violating all these standards. So they have run an audit, and then your audit score is poor. That means you have to take an action. So
So we just have to mitigate them.
whether you need Kyverno or not.
Yes.
So it can be addressed using PSA itself. So you can create a PSA and then enforce it in privileged mode or baseline mode or restricted mode. That means tight restriction on your pod security admission, right?
Yeah.
But that's only for the pods. But we are not touching other tools there, right? Pod security admission is for the pods that are violating. But consider you need a service entry. As Putuka raised in the start of the session, she raised whether we need a service entry, right? So if there is a restriction of egress, then we need a service entry automatically created. How that will be assessed? Not possible, right? So how to deny the image repository? Not possible by PSA standards, by PSA, right? PSA enforcement, that's not possible. PSA is only for pod. So the sample that I showed is only for the pod. But for pod centers and all, it's not your PSA standard, right? But it is outside of the PSA standard, can also be achieved using Kyverno.
Okay.
Basically, if you want to add any labels, add any tolerations, add any node affinity, pod affinity, so all those things can be achieved using Kyverno. Any field you can add it to any resource, any YAMLs, any custom resources. All these are possible using Kyverno.
Yeah, like you said in the example, it has to go, the label of this application should go to this node or something like that, right? Yeah. Okay. Thanks, Lav.
I have a question. Yeah. So in the starting of the session, you told we don't need any load balancer, right? I am not justified with that statement.
So you have created the cluster. Okay. And
Yes.
then you have configured the ingress controller. You have configured Istio. If there is a need for Istio, you have configured Istio as well. So that time you have deployed the ingress controller and then it created the load balancer automatically. Like, so based on your configuration, if it has to be pulled from the Azure load balancer or AWS load balancer or even bare metal load balancer. So whichever way you created the load balancer. That's completed, right?
Okay.
But after now, do you think we need a load balancer creation? I'm not talking about the Istio load balancer at all. So basically Kubernetes load balancer. So Kubernetes has 3 types of service. Remember?
Yes.
So that load balancer is required.
Okay. That is like different load balancer. Right? I mean, like if it is in AWS, we need AWS load balancer, all those, right? Before ingress controller.
Before ingress control. So I would say once you configure ingress controller, you don't need to create load balancer after that. So on a day one, you don't know, on a day one, you will create the ingress configuration, right? Ingress controller. You'll deploy ingress controller and HTO if needed, right? So that time we are not enforcing Kyverno. So if you enforce a Kyverno policy there to block the load balancer creation, your installation will not work. Your HTO or Nginx will keep on in pending state. That public IP will not be provisioned. So that at that time, we don't need to have the Kyverno policy to restrict that resource creation. But after your day one operation, day one is nothing but on your cluster delivery date. But after cluster day operation, like day one operation, it will be a day 2, which means your cluster is live, your application teams are deploying the applications, right? After this, do you think you need of creating a new load balancer? We already have Nginx, we already have Istio. So that is having a load balancer, right? And then on top of it, will you allow load balancer for application teams?
No.
In their namespace, in dev namespace, do you allow load balancer in the other namespace apart from admin namespace, like cluster admin namespace? I have a namespace called cluster admin. I have a namespace called Istio system. I have a namespace called ingress Nginx. So these 3 namespaces, if you are allowing the load balancer, rest of the namespaces, if you are denying, that means this load balancer creation is blocked for the application team because they are going to create the load balancer service in that namespace.
Okay.
That you should not allow. If you allow the load balancer creation, what will happen? The people will create load balancer. You are not restricting anything. So they will create a load balancer. If you have a mechanism to assign the IP, so you are not restricting it. It's an Azure or EKS, it's going to provision the load balancer IP for them. Behind the scenes, it's going to add a public IP for them. So imagine that 10 teams created a public IP. So attack happens. First thing, it will happen on the open IPs, right? Without any authentication or SSO, SSL termination, nothing is there on that IP. So that's going to be your first vulnerability. So that has to be addressed. So if there is any audit, first thing it will capture is that open load balancer. So that should be blocked. So you should have load balancer creation only with respect to ingress controllers. Ingress controllers, Istio or Kong or any ingress controllers for that. Okay.
Got it. Thank you.
So basically not restricting the load balancer creation for all the namespace, but allowing only load balancer creation for few namespaces. Or once you create it, then you can deny it. That's fine. Or you'll have to always exclude these admin namespaces. That's it. Admin namespaces in the sense Istio, Ingress, Nginx, and if you have specific namespace like cluster admin where you have some Ingress a load balancer IP deployed there, that also you can exclude. but rest of the namespace should not be allowed to have load balancer IP. Okay. So what I meant is that service load balancer should be disabled. So basically what you need, if you have a load balancer service without an annotation, it should be blocked. So you remember the annotation?
Yes.
Yeah.
No, yeah.
So just creating a service with a load balancer type should not work. It has to check who is allowed. So what annotation is there? If no annotation, just block it. Lot of configuration changes. You have to do.
Yeah.
So why I am saying this? Because I have seen compliance issues by creating multiple load balancers and then having it unnoticed or not auditing it. It will be a problem. Okay. Cost is one problem. Security is another problem. So both has to be addressed. That is done by Kyverno policy. Okay.
Yeah.
So this is the Kyverno documentation page. Just go through this Kyverno and then see if you have. So we are not going to cover all of the policies today. Let's see how to deploy it, and then I will enable you to explore all the best practices that you need. Okay. So basically, this is going to be architecture diagram. Any API request, any create request, it will come. So it will be authenticated. Once it is authenticated, first thing it checks for mutating admission. Mutating means changing the resources. First it checks for that rules. So if there is any rule for changing, first that will be done. Like schema validation will be done. So that will be done first, like adding a label, adding a cost center label, or adding a probes, liveness probe, readiness probe. All these things will be a mutation admission. So that once that is done, so how that will be done? Your Kyverno will invoke and then check if whatever policy that you have configured, and then it is going to change that resource. Then it will validate. Now comes the validation rules. If there are any validation rules, then it will validate. Then only the resource will be finally it will be allowed to create. So mutate, validate. So this is the flow. Okay. Sorry. So basically, this is the architecture. So Kyverno will have these many controllers to do the job. So webhook controller, every request will be watched by this webhook controller, and cleanup controller, any deletion will be handled by cleanup controller. Reports mainly for reporting purpose. So report controller is going to show you a report of what is allowed, what is not allowed. That's for the policy reports. So you have to, you just don't need to create the policy and leave it. So you have to always watch the reports, which policy is failing, so that we can fix it. That will be done by your report controller. So background controller. So admission controller will work on new resources only. So any new resource creation, it will be checked by the admission controller. But what happens for the existing resource? So background controller is the one checks all the existing resource and then checks based on the policy that we have configured, whether it is allowed or blocked. Okay. Yeah. So that's the architecture. Then Kyverno also has a CLI. You can use the kubectl apply to create a cluster policy, and let's see what we can explore. Okay. So this is one of the validating policy. So check labels. Basically, it is denying the action. So any create update pod will be denied. So what validation it's doing? It's checking environment is required, which means if I don't have this label, my deployment or my pod creation will be failed. Not the deployment creation, deployment will be created. It will be in 0/2 based on the number of replicas. It will be 0/2. It will be in that state because pod creation is blocked because it does not have the environment label attached to it. Okay. So that's on that. And for the mutating policy, so now we are checking the missing label. Now we can add the label. So match constraint. So which rule it has to check? Here it can be pod, deployment. As you said, you go if you want service entry to be created, then also you can do that. Okay. So mutation means here you can add a label called environment equal to dev or something like that. You can add meaningful labels. Okay. So that's for the mutating policy. So generating policy. So basically when you create any namespace, I think the service entry would be best example for this. I'm creating a namespace and the network policy is best example for generate policy, right? Creating a new namespace and I have to have a network policy to restrict the egress traffic to other namespaces. So that is one of the requirement, right? So you can do that. So in this case, what they're doing, they're cloning the image pool secret. So basically what they're doing for every namespace, they're creating the image pool secret. So this is one of the files that's needed. For example, I have an ACR container repository. All my application is going to pull the image from ACR. But each and every namespace should be allowed to access that ACR, right? It should be having an authentication mechanism. But do you think that they will create this registry? Do you expose this registry secret to them? No, right? Instead, what we do, we can generate this image pool secrets like that reg credential secret. So you can create a secret. So here it is creating a secret and then from the API one secret in the namespace called regcred. Okay. Yeah. And then it is fetching the reference from some variable that we have defined. Yeah. So basically it's from a secret. You can configure. Deleting policy if you want to have a scheduled job to do to clean up something. Yeah. Then you can go for deleting policy. Image validating. Yes. Of course, image validating policy, as the name says, you can check image repository. So this is for single repository, but you can add multiple repositories as well, allowed repository for your cluster. Okay. So these things can be validated, but additionally, these are specifically for signed authorities. So check that, basically check the cosign. So who is the attester for that image? So check they are valid. So those things can also, advanced image security can be done using this. Okay. Yeah. So for this EHCR image, who is the attester? What is the certificate that you can do the image validation there? And then advanced thing like you can do the cell-based expression. So resource get the config map in default namespace. So this is the cell expression for that. Okay. So nothing but an expression to pull the resource in case of you're matching any resource references. So that's what we are doing. Okay. Yeah. Basically resource list, you are listing any deployment which does not have more than one replicas, which means only one pod will be deployed. Then in that case, if there are any disruption to your cluster or node gets rotated, then application will be down. So this is one such case. Like you can check multiple replicas for a single application. So you can do that via cell expressions. Okay. So just to go through these repository and play around, but how to deploy Kyverno? So we have the Argo CD. Forward is still working. I have a link of Kyverno installation of this. I think I've deleted it, but still I will. So there is something called as finalizer. Not all the resources can be deleted using one go. So you'll have to delete the finalizer, then only that resource will be deleted. So finalizer is nothing but way of enforcing the save deletion. Okay. Get application namespace Argo. Argo CD. See these many application. Then edit application. My Kyverno, I have deleted it. So due to finalizers, it's not able to delete. So if you see, I have a deletion timestamp here. Now I have a finalizer which is blocking my deletion. Just removing the finalizer. So it should delete the application. So,
This finalizer gets created for all the resources, Lavanya. Like I was facing some issues, but I was not knowing which resource I have to delete or the which resource has the finalizer attribute. I have faced this
so
in one of my project.
yes, it's based on, for example, if you deploy Kyverno,
Yeah.
so not all of the, so if you delete the Kyverno, not all of the resources are deleted by default. So there are critical applications. So those
Yeah.
which hold back. So it will not be deleted by default. You'll have to forcefully remove the finalizer on the Kyverno. So now this is my master application. So I have what I can do, I can remove the finalizer in the master application, and then it will delete the rest of the application. Or else otherwise I can go ahead in the deployment, delete the finalizer there, delete the finalizer in this cron job, delete the finalizer in this cleanup job. So all these are critical controllers. So controllers will not be deleted by default as you just give delete command. So it will have finalizers. All the critical controllers and resources which are managing other resources will have finalizer. So you'll have to delete the finalizer either on all of the resource or identify the master resource and do the deletion there. Yeah, the finalizer.
Okay.
Okay.
Yeah.
I think CRD. So when you deploy any help chart, you will face such issues like CRD deletion will not happen by default. Okay, so you'll have to forcefully delete the CRD. So that's one thing. But for the demo to keep going, I can do one thing. In Kyverno, I will change the Kyverno app, and then Kyverno system namespace. Another namespace I'm deploying. So now I have the Kyverno app. So it's creating. So this helm chart is having some issues. So too long. So there is an annotation which is too long. So it is happening on one of the critical resource, which is your policy and cluster policy. These two are important things. Let me check if I have some CRD files which will be deployed. If anyone can do the lab parallelly also, that would be good. Meantime, I can fix the CRD thing. Argo CD is not working at the moment. Let me fix that. So basically you can deploy this CRD by fixing the annotation thing manually and then keep it going, or check the annotation which is too long and fix it. But I would like you to go through the lab. So basically we know how to deploy the Kyverno, and then you have Argo CD to fix the errors. And now what you have to do, you have to go through the validate Kyverno policy. So I am creating a cluster policy. So the difference between policy and cluster policy is, as by the name, you know, it can be validated across the cluster. Okay. So I'm creating a guardrail. So this is the best practice that I'm enforcing for my cluster. So what are the validation enforce? Okay. And then does it has to validate the existing resource? Yes. Background is true. So rules, you can create n number of rules. So each and every rules for one recommendation. So first rule is require label. If it requires a label, what type of label it is required? It's not validating what the value is there, but it's validating the key. It can have any values. So this is the pattern. And then if it violates, it is going to throw this message to the user, either in the Argo CD event or in the kubectl apply command. So it's going to pass this information. And then this is going to be for non-root user. And then you can add disable privilege escalation is another best practice. Require probes, liveness probe configuration. There's another best practice. Readiness probe and require resource and limits. So you should configure resource request and limit. This is one of their best recommendation. Otherwise, they can consume the entire cluster if their application is not performing well. It's spinning up a lot of pods due to misconfiguration. You'll have to address that. So they should have the resource request and limit configured. So that's one of the policy. And then disallow the latest tag. So these are all the validating policy. So you can configure the mutating policy as we have gone through the Kyverno website. And then to configure adding these labels. So for each of these validating policy, you can add a mutate policy as well. So add the best practices labels and then make it, even if they mention true, make it false and deploy. You should not block them, right? So you should not block them and then wait for them to fix it. So you should do something. So you'll have to make it false and then deploy. So by default, they don't know what they're doing. So they will add more privilege by default. They will check the reference from online and then they will take and deploy. Is it really required? No, right? So you can make it false and deploy. Similarly for this. So yeah, make it true and then deploy. Add a liveness probe based on the container code that they are mapping. You can add a liveness probe, readiness probe. And for this, we don't know what will be the tag, right? So they should not be using latest tag. For this, there won't be any muted policy. They will have to adhere to this policy. Okay. Is that clear? Okay.
Yes.
Then I want you all to go through the lab. So we have a single validate manifest. So create 4 different manifests and then create a violation YAML. So create a deployment with this, without having this app and env label, it should throw this message. And then it should also give me this guardrail name. This require label is failing. That is going to give me all the details. So you have to explore it yourself, what is needed. Okay, so it's going to work for me even if I just fix the CRD, but I want you all to explore all the possibilities that are there. Okay, I think with this we can end the session today, and then let's see. Let's continue in the next session. Yeah. Any question?
In the next session, can you please little brief on node affinity, tains and tolerations?
Yes, I want to do that. I think we are over time. I just took few details for that. So maybe we will just share it in the next session.
Yeah, sure. I mean, I was also planning to ask the node affinity and pod affinity, right? So probably
it's not going to be a difficult thing. So yeah, we can cover it in 5 or 10 minutes. That's fine.
Lavanya, like initially we did the application through Argo CD, right?
Yep.
Like, is it possible to bootstrap everything from the Terraform? Cluster creation, Argo CD configuration within YAML itself, kind of.
So cluster bootstrapping is one thing.
Okay.
So with cluster bootstrapping, you can deploy the Helm chart of Argo CD.
Okay.
So once you deploy the Argo CD, then your cluster is able to bootstrap from the Argo CD, right? Like then you will be able to onboard the application. So bootstrapping is done using Argo CD, but to deploy Argo CD also, you need the mechanism. That can be done using Terraform. So when you create a cluster, we should have the bootstrap mechanism. So that should deploy all the tools required. So basically, you can deploy all these HTO, all these whatever tools that we were discussing, cert manager. So all these tools can also be deployed from Terraform. But do you think we need everything to be handled by Terraform? No. All that you have to do is you just have to bootstrap or start. Bootstrap is nothing but start the cluster with minimum that's required. So you create the cluster and deploy Argo CD. But after deploying the Argo CD, create a single application where all these YAML files are there. Basically, application manifest are there.
Okay. So we can place these YAML files and that will automatically.
Yes, you can first install Argo CD with Terraform. That's it.
Okay.
Then first master application also you can install using Terraform. So it's going to watch a repository, KH infra. That's my repository.
Okay.
And then I have 10 folders, 10 apps inside each and every folder. So it's going to watch all the folders and then it's going to sync all the details required. Okay.
Okay.
So if some tools needs a secret, then you need a secret management tool as well, right? So either you need a Helm secret or just have an integration to pull the secret from external secret manager. So yeah, so you just need to configure them. But once you have the Argo CD deployed, you can manage all the application, be it infra, be it application teams.
Okay. So now, like our main cluster is up. If I have to add additional clusters, do I need a Argo CD agent or something to run on those additional clusters automatically?
For which one?
If any additional clusters to be added to the Argo CD.
Not required to have additional agents. All that you need is maybe you can add more and more controller replicas.
Okay.
So based on the load, based on the utilization, you can add more replicas. That's it.
Okay.
You don't need to have multiple agents running in Argo CD. There is no